In the tundra where the chill gives birth, rises a beacon of unmeasured worth. Yakograd stands with its banner so bold, a land of a story that's yet to be told. Oh, Yakograd, we raise our cheers. Through icy winds your voice appears. The Yak, our guide, strong Commissary J, the future's new. Fields of frost silver, rivers that gleam. Every heartbeat swears to the dream. From peak to valley, our pride won't fade. In the Republic, the greatest is made. Oh, Yakugrad, we raise our cheers. Through icy winds, your voice appears. The Yak, our guide, strong, steady, and true. With Commissary J, the future's new. Every storm we weather, we stand refined. EJ, commanding both heart and mind. The Yak shall graze where the heavens bow. To Yakugrad we make this vow. Oh, Yakugrad, we raise our cheers. Through icy winds, your voice appears. The Yak, our guide, strong, steady, and true. With Commissary J, the future's new.
Okay, what's going on, everybody? Welcome to the Space and Rocket Review. It is April 1st, 2025. And I am EJ, your host, Space and Rocket Review. You two girls, tell your friends, Space and Rocket Review. Okay, so for this Space and Rocket Review, I'm going to do things a little bit different this time around. What I'm going to do is tell you all of the space news over the course of a 3-hour period in 2 seconds. Yeah, we're going to condense it all down. We're going to try a new thing here so you can get your news faster. So here's what we're going to do. Ready? I'm going to convey all the news really, really quickly, about 2 seconds, and then we'll be done. It'll be great. So you get more information per second. All right, ready? Here we go. There you go. I hope you enjoyed this space news. I'll see you guys all tomorrow. Have a good night, and thank you. It's April Fool's Day. Sorry, I don't know. That definitely didn't need to be a thing for April Fool's Day, but I figure, we'll do it. We'll do it. It'll be good. It'll be good. Anyways, about that pillar of a very informative. 10 out of 10. All right, with Space and Rocket Review again. Great. Okay, so welcome to Space News. There is a lot of stuff to talk about. I didn't really get to doing Space News much yesterday because of the From 2 mission. Yeah. So we didn't get to do too much. Oh, the Ars article, 1,000. Oh, you want to talk about that? Don't worry, I got that one teed up. Can't see me? What's going on? I got the big speakers on. Feel free to pipe some of the great thrust audio through the system. It's April the 2nd, you fool. No, it's not. It's 5:09 p.m. on April 1st. That's what my computer's telling me, and this is my stream, Pi. This is my stream, buddy. My stream, buddy. I'm the main character. All right? This is my stream. You know, it can be April 2nd or April 3rd or 4th or heck, it could even be 5th. But remember, it's April 1st. Here, where I'm at. And if you ain't first, you're last. My mom says it's my turn to be the main character. No. All right. Can't see me. I don't want to play the guitar right now. So jump. Oh, look. We didn't get that very far before someone's telling me to jump to a random time in a YouTube video. Gully, what's on your mind? Ranger ad. That's great.
Go, starting off slowly.
Here, let's copy at current time. Pop it in here. Let's see. Dude, get off this. More ads are coming through. They're getting worse. Okay. What do you want me to see here?
Now, oh my God! Oh my God, that's an aborted takeoff. Holy sh!
Okay.
All the roar. 3002 on up to Ronnie, 8 right, clear for takeoff. On up Ronnie, 8 right, clear for takeoff, 2002.
Teddy 02. Here we go. Starting off slowly. Very slowly. Now, oh my God! Oh my God, that's an aborted takeoff. Holy sh! Oh my God! I cannot believe I just saw that.
Yeah, that's very broken. Yeah, that's I didn't know the KC-135s had an afterburner. Yeah, that's not good. Oh my God. As far as I can see, there's no news about From 2 with their RCS. Yeah, it's, like I said, it's probably not a lot, but oh look, that's parts of the engine getting shot out the back there. Yeah, see all these little specks? Yeah, that's... Yeah. Any bird around? No, I think that's just if I had to guess, that's probably your fan blade failure. It's not a compressor stall. That's FOD ingestion all day. See all the sparks? That means something went into the engine that shouldn't. And I didn't see anything go into the front of the engine. So that means the fan blades from the turbo, from the ducted fan looked like they came apart and went into the compressor. That's what that looks like to me. Ugh. What would be a specific impulse in this case? What? Hey, Thick, what's going on? Yeah, I don't know what that means. A joke, it was a joke, I'm sorry. Oh, okay. The specific impulse? No. No, that's what it would be. Shoot. Yeah, that's, Oh, see that plane over there? Fun fact. This is a 4-engine version of that plane. Or is that a 2-engine version of that plane? Which one would you guys call it? I mean, I didn't see the cowl or anything break, but the family. Which came first? The KC-135 is based off of the 707. The 707 came first. The 737, right? The 737 is a shortened 2-engine version of a 707. Fun fact. Look at the tails. See what I mean? Look at this. Look at the profile of the fuselage. The engines. Now, so that looks to be over there like a probably 730, no scimitar wing. So 738 maybe. That's not a max, right? But it does have the winglets. It could be a 737, 737-700. So 737 is what that would be called. The plane in front is a 3-engine version. Yeah. Yeah, that's right. That's right. It goes in the square hole. The interesting thing is that KC-135s are tanker versions of a 707 for in-flight refueling because of the fuel boom in the back. See this little thing? This thing can actually retract down and in-flight refuel like a fighter plane or whatever. Right? And there was a KC-135 upgrade program that upgraded the KC-135 with the engines that the 737 was upgraded with. I believe those are CFM56s, I think. If you look, that 737 has a very similar motor on it. They're very similar because they're pretty much the same. So what came first? Technically, this one did, but this version of the KC-135 was made based off of that version. Well, technically a 737-400 if we want to be very, very specific. But yeah, CFM whenever the actually I'm not sure. Whenever the 747 was refitted with CFM 56s. But yeah, those two planes are very similar. At least passing. But they come from the same family of airplanes. This is just a 4-engine version of that. Yeah. Pretty cool, huh? Check your Twitter. I chagged you in some nightmare fuel. Okay. Hmm. Give me 1 second, guys. I'll be right back. The computer out in the garage just started playing a YouTube video randomly without any autoplay on it. That was strange. Where's Titan? Titan's down in the house. Is this a new chair? Yes, it is. I said the 2-engine version is weak, and thus this is the copy. Yeah, maybe. Marcus is just out in the garage. It's the shop chair now. Did we get any views from the From 2 mission yet or no? Yeah, okay, so here. Let's get into space news. Yeah, Goalie, that motor's junk. That's junk. Write it off. So SpaceX posted this shortly after From launched. If you haven't seen it, or you don't know about this, last night the From 2 mission launched, and it was the first ever crewed mission to a polar orbit. This is the first time anyone has seen, the crew on board were the first ones to witness this. This is the first time anyone has seen the North Pole from space, or the South Pole for that matter. That's pretty good, dude. Look at that. Yeah, those are pretty good. Those are pretty good views. Hey, Chief. Do we have any ETA on Dragon's return? It's 3 to 5 days, Talon, so got a couple more days up there, at the very least. I wish we had the scale of those mountains. Yeah. I see Santa's house. Oh, Coco, I gotta go poopy. Oh, man. Sorry, I got another link. Any updates on the apparent thruster misbehavior? Nothing. We've heard nothing, friend, and because it's a commercial mission and SpaceX really doesn't have any responsibility to or duty to tell us anything about this mission, with the exception of the views that they're posting, we'll probably never know. For all we know, that could have been normal. I don't think it was, but for all we know, it could have been. So, what am I talking about? So From 2, right when it separated last night, had some very weird, it had some very, very interesting thruster outgassing going on. I've never seen Dragon do this before. Now, I don't know if it was on purpose or what, but this didn't look like it was on purpose. Here, let me show you. I'm trying to find the stream if you haven't seen it. I don't think it's anything. It's probably nothing. Even if it was something, they probably wouldn't tell us. Where the heck is the From 2 restream? Oh, it's pinned. That's why I couldn't find it. Yeah, they didn't show the they didn't oh, there it is. Okay, I got it. All right, here we go. So check this out.
Separation.
So this is right at separation, right? You can see the Starlink placer that's in there. That's a Starlink optical antenna or optical transmitter right there in the trunk. Now watch. Let's get a little bit further. Oh, they didn't show it. They cut it. All right, let me see if I can find it. Where the heck is it? Did they get rid of the froms? Where is that? Where's that stream? Oh no, I saw it. It was linked right there. There we go. Okay, so check this out. Here, watch. So Dragon is going to do a thruster checkout. That's one of the first things that it does. And we've seen it do this before. It's just basically pressurizing the onboard thruster systems because they're pressure-fed thrusters. You got to pressurize the tanks to get them to work. So we see a thruster checkout. There it is. That's what it usually looks like. Now watch. Did you see it? It was quick. There's more of that. See that? That's not... Dude, I don't know what's going on there. I don't... That doesn't look right. That doesn't look right to me. It doesn't... You know, I don't know. I could be out of my mind. I've never seen the thrusters keep doing that for like 15, 20 seconds. Thruster checkout usually takes 5 seconds at best. So that's what I mean when I say I don't know if we're going to hear anything about it. That definitely looked a little bit on the strange side of things. I don't know. It's probably nothing. Yeah. The hosts, Jesse and John, noticed it. They looked at it and they were just like, all right. And it's separated. Okay. As of 2 hours ago, Raptors are going into High Bay 2 for Ship 35. Cool. I'll have more Starship updates in a little bit. What if the capsule can't do the deorbit burn? Dragon has thruster out capability. He can lose 4 to 6 depending on where they are. Now, with all that being said, we have a report from the Orbital Police from Jonathan McDowell here. First Space Force orbital data for FREM 2. Showing a 202 by 413 kilometer orbit at 90.01 degrees inclined. There you go. I think you want to do that before separation. What would be the difference? 90.01 is pretty good. To get your inclination to the 10th of a decimal point is pretty good. They're technically retrograde. Yeah, FREM 2 is the first crew to ever be in retrograde orbit. They are technically by 0.01 degrees in a retrograde orbit. Yep. That's pretty cool, man. So, yeah, I'll give you guys updates on what's going on with FREM 2 as we hear more about it. But the views are, the views are woof. Oh, yeah, that comment from John was kind of sus. Yep. The thruster's not supposed to do that. But, whatever, it's clearly not an issue. Yeah. Yeah, that's pretty good. That's pretty good. So that's the South Pole right there. Oh, headset went out. Hold on. And then it'll switch to the North Pole here in a second. That's the North Pole. I'm not sure what we're looking at over here, like where we're at, but that's amazing footage. So yeah, I'll give you guys updates on it as much as I can hear it. So next bit of news, we got a good shot here from Tori Bruno looking inside the Spacecraft Processing and Operations Center, or the SPOC for short, which is down the street, proverbially, from Slick 41. Tori Bruno posted this shot. Here's another cool shot. 2 Vulcan mobile launch platforms at VIF A at the same time. I'll tell you what I'd do, man. I'd launch two rockets at the same time on 2 launchers at the same time, man. Yeah, ULA is building 2 mobile launchers in there so they can support 2 Vulcans being built at the same time, which is pretty cool. They're also extending the roof. They're also extending the roof so they can stack the full rocket and putting a new gantry crate in the SPOC. The SPOC is the former solid rocket motor assembly facility for the Titan program. Now, just on a really quick side note, it kind of sucks that they're scaling like crazy. Because at one point, give me one second. At one point, so Slick 40 and Slick 41 used to be this part of this of a launch complex called the ITL, so Titan ITL. It's the Integrate, Transfer, and Launch Complex. Here, let me show you. And it's interesting that they're retrofitting the leftover buildings from that program. Solid rocket motor assembly, solid rocket motor integration. I'll show you why. I'm just getting some pictures teed up here. Should have probably teed these up before, but... because the ITL causeway here, let me show you a picture of what it used to look like. So this was specifically for designing Titan rockets, or building Titan rockets. You had your vehicle integration building, solid rocket motor assembly facility. The SMARF is right here nowadays. That's the building that ULA is working in right now is not built in this picture. It's right here. Solid rocket motor processing and solid rocket motor assembly, excuse me. I said them wrong. And then you had Complex 40 and Complex 41. Complex 40 is used by SpaceX. It's used by SpaceX for Falcon, obviously. There's crew access arm and everything over there. The solid rocket motor assembly building is also used by SpaceX for staging payload integration. So that's where they, put Starlinks inside of fairings and amongst other things. Complex 41 is used by United Launch Alliance. And then there's a building right here, just outside the pad perimeter, called the Vehicle Vertical Integration Facility. That's where they build their rockets, right? And I told you the complex that ULA is working on right here is the SPOC, right? Which is the former solid rocket motor processing facility, right? For ITL, right? In there, like I said, they are building up. They have 2 mobile launchers and it looked to be able to support integrating 2 vehicles at once, because ULA needs to scale, because they need to launch Vulcan a lot because of Project Kuiper, because they got a huge contract with Amazon and another huge contract with Uncle Sam, right? I was going to say, it's a pretty darn shame that, after the Titan program ended in the late 2000s, they demolished the 4-bay vehicle integration building down here. Not a lot of people know that at one point on the ITL Causeway, you had the provisions to build 4 rockets. there was a gigantic vehicle integration facility here. A 4-bay VIF. Man, they could have used that right now. They demolished it in 2009. Not sure why, but they did. I don't know who made that decision, but whatever. Hey, New Zealand, I'm doing all right. When is the next launch space? 8 o'clock. 2.5 hours away. We have a Starlink launch, 11-13. It was not being used at the time, Isfil, but it's interesting to me that they chose to just demolish the building instead of trying to see if anybody wanted to rent it. A building like that would be prime, especially in this spaceflight economy. But yeah, unfortunately, they demolished it, and now it's a really, really nice field. Yeah. And they also ripped up all the tracks for mobile launchers, which, yeah, it's kind of annoying. What time will that be in the UK? The time is now 10:30. No, I'm not playing that game. I'm not converting to your time zone, dude. That takes way too much time because if one person does it, everybody does it. It's 2.5 hours from now. So, see, it's a field. It was right there, and they got rid of it, and it's a field. Is the building about to collapse? No, it probably just didn't want to maintain it. See, it was there. Yeah. Okay, sorry about that. Sorry about that, my bad. It's all good, it's all good. Yeah, it's a pet peeve of mine. Dude, I'm hosting the stream. I would love to just do time zone conversions for everybody, but I'm sorry, chat. I'm afraid I can't do that. So, yeah, just thought it'd be cool. That'd be cool for them to use, but looks like they're stacking two of them side by side inside of the spacecraft processing area. The spacecraft processing and operations facility, which once again is down the street. And then they took the switcher locomotives that they used to tow Titans and they put them in a field somewhere. Well, Space and Missile Museum, but it's very annoying. Yeah, the ITL Causeway, man. Big launch complex that the Air Force built. And they used it. They used it for about 30 years. To launch Titans from 40 and 41. But, not anymore. Like I said, shame. They, that would have been very useful having, a bunch of those, but it's all good. Are those diesel, electric, mechanical, or hydraulic? Those are EMD switchers. That's an EMD switcher. That's what they used to use to tow the missiles to the launch pads. In fact, the tracks on some parts of the pad are still there for the locomotives to tow. Someone is upgrading the Delta Operations building. Cool. I meant, what's the powertrain? It's diesel electric. Yeah, the pads, you can see where the tracks. See, they'd tow the thing through there, and the locomotives would go into the building. See, could go in the building. I thought it was cool. Or you could just push it up there. Where do they store the Cheetos? I believe those are kept, the Flaming Hot Cheetos are kept in munition storages over here. Yeah, see, there's your munitions bunker, Nubius. Yeah. Gotta be careful with those things, you know. Cheeto dust is very, very flammable. Anyway, It's cool to see the former ITL Causeway getting some serious action. I mean, Slick 40 is one of the most used pads in the world at this point, and 41 is right behind it. Do you think it's a logical thing to not catch Booster 14 next flight because it will be reflown? I don't know. I have some stuff about Starship over here on the tail end of Space News. Titan 4 is one of your favorite rockets. Oh, yeah, good stuff. So, another quick bit of space news. United is now fitting their aircraft with Starlink, so I think they blurred out a lot of stuff. I think, what is that, an Embraer? Embraer 190? Ooh la la. Did you see the Rocket Lab thing you posted? No. I got the link now. It's a SkyWest Embraer 175. All right. Cool. Ain't no SkyWest flying a 190. Ain't no SkyWest flying that. Direct link, seeing as it's Twitter doing Twitter things. Why do you constantly link me to stuff like this, Gratian? Why? So yeah, we got Starlink on United. I'll tell you what, and I'm not being paid by United or anything to say this. I flew United on the way back from Boca Chica the last time I was down in Starbase. I must say, it's a lot more pleasant experience than other airlines. Go on Google Earth and try to find Dragonland. United is the only airline at your local airport, so I fly with them. Nice. No, their in-flight entertainment system was quite good. Nope. I don't care. I don't care. Just refurbish the stupid capsule. Where is it? You're about to tell me. Yeah, Hangar K. Got it. It's across from Hangar X. Did you get the Flight Club upgrade with United? No, I didn't. I prefer Spirit because I get to fly a leg of the flight where the pilot takes a nap. M and K are both owned by SpaceX. Yeah. Yeah, that's good. Yeah, I can tell that SpaceX is the one that's using these. You know why? Because the parking lot is full and there's stuff everywhere. And I mean that in an enduring way. You go to these other facilities, the parking lot's empty and nothing is going on. So, you know. You know. Yeah, it's Cape Canaveral Space Force Station. They built a lot of hangars out there. Yeah, none of it is accessible to the public, though. Which is what it be, so it do. Who owns the empty ones? The Space Force at this point. SpaceX would have taken this one, but that one is the Space Force's super advanced cloaking device. Anyway, let's keep going. So, this was coming by a user on X named Taylor that I'm not too familiar with, but apparently Taylor is part of the Artemis 2 closeout crew. Lead Orion Command Service Module Flight Technician. And Taylor posted some pictures of the Artemis closeout crew truck, which is actually pretty dang cool. Pretty cool. It very much looks like just a UPS truck, but the inside though is pretty neat. So the closeout crew are basically closeout crew to SLS and Orion is basically what pad ninjas are to SpaceX. This is the last people that are on the pad before launch, and this is their vehicle for getting to and from the pad. Pretty cool. It looks like the truck that the bakery uses to deliver the bread to the restaurant you work at. It probably is. I'm not sure which type of van this is. It could be a Grumman van. Hold on. I'm just looking at the front of it. Give me one moment. I don't think it's a, no, it's not a Grumman van. Grumman used to make vehicles, by the way. That Northrop Grumman, they made the mail vans. Believe it or not, that's one of their most mass-produced vehicles, the Grumman LLV, which is the mail van in the United States still, and it's been the mail van for like the past 40 years, maybe at this point. Question. It's the Snap-on van. It kind of looks like that. But either way, yeah, cool. It's cool to see the closeout van is not some crazy defunct electric vehicle company. You know, because it actually has to do work. Moving on. Okay, so the FAA has closed its mishap investigation into both January Starship flight and the first New Glenn launch. So that's Flight 7 and NG-1. For the latter, the booster was lost attempting a landing because of an inability of New Glenn's first stage to restart the engines. Ooh. Space Force to test satellite refueling technology. That's cool. Bill, right on. We do not talk about the new mail vans. They do not exist. That's right, Archie. They don't. Yep. So, Starship Flight 7 mishap. The FAA required investigation of Flight 7 on the mishap on January 16th is closed. There were no public inquiries, no public injuries, and one confirmed report of minor vehicle damage in the Turks and Caicos. The FAA oversaw and accepted the findings of the SpaceX-led investigation. The final mishap report cites the probable root cause for the loss of the Starship vehicle was stronger than anticipated vibrations during the flight led to increased stress on and failure of hardware in the propulsion system. That's very vague, but well, all right. SpaceX identified 11 corrective actions to prevent a reoccurrence of the event. Should have done 12. The FAA verified that SpaceX implemented corrective actions prior to Flight 8. You sure about that? You sure about that? Are you sure about that? You sure about that? Okay. Well, those corrective actions weren't corrective enough, I guess. Flight 8. Okay, so if you're missing context there, Flight 8 blew up. It did the same thing. I mean, I laugh because I know it's not gonna bother. That's not a big deal in the long run, but it's still kind of funny. You can't make this up. It's like the funny stuff that we're gonna get to a little bit later. So, with New Glenn, Blue Origin identified several corrective actions to prevent reoccurrence of the event. The final mishap report identified the proximate cause of the mishap as an inability of New Glenn's first stage to restart the engines, preventing a re-entry burn from occurring and resulting in loss of the stage. RIP. Blue Origin identified several corrective actions to prevent reoccurrence of the event. The FAA will verify that Blue Origin implements corrective actions. Okay, well, they haven't flown Flight 2, so we'll see.
You sure about that?
You sure about that?
You sure about that? You sure about that?
You sure about that? Yeah. You sure about that?
You sure about that?
All right, I'm keeping that one teed up. We'll keep that one teed up. You sure about that? Yeah, it's also pretty light on the details. How far along is the hardware for Flight 2? I can't see Blue not flying in the next couple of months, Yum Food. I can't put an exact date on it, but I would say at the very, very, very latest in the summer, they're going to fly again. What are the odds that they have the same problem happen on the next Starship launch? I don't know. We'll see. But it seems that Blue Origin cannot get away with not doing a reentry burn. Yeah. Maybe. IMO New Glenn has a 70% chance of sticking the landing on the next launch. The problem was with the engine bleed control and propellant management system. Yeah. The FAA is overseeing a SpaceX-led investigation of Flight 8. The investigation remains open. A return to flight of the Starship vehicle is based on public safety. SpaceX may not launch Starship again until the FAA accepts the final mishap investigation or makes a return to flight determination and all other licensing requirements are met. Contact SpaceX for more information. All right, so Dave Limp commented on what was going on here. So it's from an original post. The original post was from Blue, but we'll read the original post first. We submitted our final report and fulfilled our obligation to the FAA regarding the NG-1 mission. Regarding the NG-1 mission booster landing attempt, New Glenn launched successfully on January 16th, achieving our goal to reach orbit and deploy Blue Ring. Our ambitious attempt to land the booster, so you're telling me there's a chance, was unsuccessful due to our 3 BE-4 engines not reigniting properly. A review confirmed that all debris landed in the designated hazard area with no threat to the public safety. The report identified several corrective actions focusing on propellant management and engine bleed control improvements. Oh. Propellants weren't settled. Yeah, they didn't settle the propellants there, and the engine bleed didn't engine bleed. So that fire that we saw probably coming out of New Glenn at the bottom is probably not from the rocket engine. Debris landed. Sounds like a hard start. Yeah, Wisp, absolutely. It's definitely a hard start. I always talk about how thermally conditioning your engines is important. Because if the turbo pump gets hit with super cold propellants really, really quickly, it's going to explode. Yeah. If they didn't have the right head pressure inside of the tanks during the engine relight, you're not going to get a good... Your bleed systems won't work correctly. I mean, it varies by design, but that... Yeah, that's if their thermal conditioning was not working correctly due to improper head pressure from the tanks, that's not gonna work. That's not gonna they're gonna go to light the engines and they're gonna blow up, which is basically what happened. Supersonic retro explosion. Yeah. You want to do SSRP though, Repairy, not SSRE. That's not supersonic retro explosion is not what you want. You don't want that. You don't want that. Which we're already addressing. We expect to return to flight in late spring. We'll attempt to land the booster again. Yeah. I'm pretty sure they'll confidence would be pretty high for the next one. Encabulator malfunction? Oh, yeah. Yeah. Exoatmospheric entry burn. Yeah, we're doing an exoatmospheric entry burn here. That's really what I want to do with Blue Origin. We want to really capture the operational excellence, you know, by doing the exoatmospheric burn. No, it's not called supersonic retropropulsion. I won't even say that. I love how in that video Taco Bell Jeff was like, "Yeah, no, I'm not calling it that. It's exoatmospheric reentry burn." Like when SSRP emote. I'm out of emote slots, Chief. You guys demanded too many emotes. I don't have any more. Subscribe more, I guess. You want to unlock more slots. Sorry, I don't ask for. We don't ask for that. Though I must say, I don't have much faith in the Fin Control Authority at Mach 5. I don't necessarily think you need that much control authority with those things, Baron. The shape of the booster and the big wings that are attached towards the bottom of it, that wing basically means that you don't really need too much control authority on those fins. That's probably why they don't have grid fins and why they're using regular fins, because the big fin at the bottom of the New Glenn first stage. That's for the uninitiated. That's this thing down here. See that? It's not going to take much of an angle of attack change to deflection change on those, like those top fins. It's not going to take much, you know, to steer the booster at a point where you can use the differential pressure on top and bottom of the wing to slow down. That's why that's my belief why they're not using the grid fins. And why they're using fins. You could just turn, you don't need to turn this a lot, you just turn it a little bit. And I know what you're saying, but turning it a little bit isn't going to do anything. Yeah, maybe. But dude, even if they can get this thing to destabilize a little bit, destabilization, meaning like them trying to steer that booster in, even a little bit with that wing is going to slow down. It's going to slow you down a lot. You don't need that much deflection to get this wing to start doing work. I'm not trying to say we did this in Kerbal Space Program, but we absolutely did this in Kerbal Space Program, and it absolutely does work. Yeah. I mean, obviously, Kerbal is not real life, but also, you're not going to need that much. This one is fixed. Thick? Yeah. This one, those ones move. Circular booster wings would work too, right? Yeah, it's possible. Toroidal wings could work, yes. Give me one moment. I'm trying to find a picture of that dang thing. Where the heck is it? Where the heck is it? Ah, there we go. Yeah, toroidal wings are a thing. Yeah, that could work. I saw a slight image of the wind tunnel article of that thing. You won't believe the amount of drag generated by the aft section since it's surrounding the engines. Yeah, that's what I mean, Baron. You don't need that much deflection. It's going to generate a ton of drag, and even if they can do a slight like pitch rate change, it's going to slow down like crazy. In fact, I'd be worried about it getting ripped apart. Yeah, circular wings could work. It's possible. Oh, nice, Baron, yeah. Ring wing, yeah. I'm talking about what we did in Kerbal was see where the fuselage of this quote-unquote jet plane is? I put a rocket right there. I put a first stage with the inner stage up here with control surfaces and the engines back here. So when you launched, this thing works just like a stabilizer wing, like if you put fins down at the bottom of your rocket. When the thing boosts back and comes back down to land, this thing generates crazy amounts of lift, and then you can just land your first stage on a runway. This is a real idea. It was a French jet before they figured out before like the Harrier came along. This thing, they would put it on this strong back, right, and it would turn it upright and it could VTOL. And it, when you wanted to land, it came in like this, right? And then entered a hover and then landed. I forget the name of the dang thing. The snack, yeah, here. Yeah, this thing. Yeah, see? Look at that. Look at that thing. It's just an engine. That's the wing, guys. Think like if you took a plane with a delta wing and you just wrapped the delta wing around the fuselage. Yeah. Toroidal wings work, or just, well, ring-shaped wings. That's absolutely a thing. And in Kerbal, we tested putting, like, see where the fuselage is, like I said, putting a rocket there instead. It definitely works. This thing flies, fellas. It flew. It's just kind of hard to land. That's a render, but it's definitely a vibe. Definitely an interesting design. Yeah, that's definitely a vibe. Anyway. So, yeah, it's not gonna. We'll see. I think Blue has a. Well, I mean, this is kind of like not a shocking revelation. If fluid management was the only problem they had with that thing during deceleration in their exoatmospheric landing burn, I would say that their odds of success for the next landing are pretty high. How does it land? VTOL. So that thing comes in like this, the circle part is right here, and then it does this, noses over, enters into a hover, and then lands. Yeah, that's about as sketchy as you think it is. There's a reason why they didn't use it. Yeah, that's about as sketchy as it sounds, because it is. Either way, New Glenn was awesome. That was a really good launch, and I really want to see more of this bad boy. It's a big vehicle. I mean, it kind of gets overshadowed because Starship is just that much freaking bigger. I mean, Starship is the size of the damn tower that's next to this thing, but this is still a gigantic freaking rocket. And its upper stage is amazing, for what it's worth. Yeah, 7-meter fairing. Biggest fairing to ever fly. And it worked. Just don't want to stay awake till 4 in the morning again. Yep. Tell me about it, Sea Kraken. I covered that, and then I went to bed for 2 hours, and then got up and did Starbase stuff, like, right after that. It was, most displeasing. Have any reusable stages ever been reused to date? Any reused more than once? If you're talking about Blue, no. Blue is never reused an orbital class stage. They've reused their New Shepard rocket. So that New Shepard rocket is the one that goes up and comes right back down. Those have been reused up to 4 times. If you're talking about like just straight up booster reuse, SpaceX has multiple Falcon 9 first stages that are well above 20 flights. Yeah. So, I mean, if you're asking generally, Tomato, yeah. Yes, a lot. I think SpaceX's life leader is at 26 flights, which is a lot. How much smaller was Skylab's fairing compared to New Glenn? 6.6 meters on that fairing, NG. Dang, I love it. Thank you. No one. There's only one entity that has reused the second stage. To this day. Spoiler alert. It had these attached to it. There's the shuttle. The record for most shuttle reuses is Discovery with 39 flights. It's pretty awesome. Yep. Anyway, so we got another update here from Impulse Space here. So Impulse is building their own COPVs. Best way to tell if your COPV can handle the intense forces of a launch, put it to the test. During launch, forces from acceleration put serious stress on COPVs. To ensure reliability, we run external load testing by pressurizing the tank and applying static loads of over 10,000 pounds with a hydraulic actuator. Welcome to Hydraulic Press Channel. Today we're going to crush a very dangerous COPV. Very good. All right, see you, buddy. Validating the article can handle well beyond the harshest flight conditions. Cool. Yeah, they're making their own bottles. That's a composite overwrap pressure vessel. That is basically a titanium tank that's wrapped in carbon fiber to be able to withstand very, very high pressures inside. You can hold a lot of gas inside of these COPVs, like ullage gas for a rocket. Rockets do have residual gases that they take up, like pneumatic systems that they use to keep the tanks pressurized over flight. Think about it. When a rocket goes up, it's burning liquid fuel and oxidizer. Your tanks are draining. If you didn't replace that with something, right, your tank pressure would drop, and you have to maintain the right tank pressure to be able to feed at the right rate, at the right fuel rates. If you don't feed liquid fuel and oxidizer in the right way, however the engine wants, and you go one way or the other, the thing will blow up. So a lot of rockets use what's called ullage gas. They use pneumatic gas that's pumped into the tank to take the place of the propellants that are draining out. So that's what those things are. Impulse Space posted that, and they're working on building methane third stages for vehicles. So like something that could go on top of, say, a Falcon 9, for instance. Like you could put it inside a Falcon 9's fairing and make a little space tug. That's what they're working on. That's a COPV for one of their third stages. Impulse Space was founded by a guy by the name of Tom Mueller. Tom Mueller was one of SpaceX's first employees, and he designed the engines for Falcon 9. So, yeah, we keep an eye on Impulse because, yeah, they're doing cool stuff. So, that's it for all the quick news. There's some... I have Starship news, and then there's some kind of spicy news. I don't know. You guys tell me. There's some interestingly spicy news. So the first one that I'll show you. Well, that's it. Thanks for watching. Yeah. First one that I'll show you. I thought you went to get beer. No, not yet. The first one here is coming from Charlie Camarda. Charlie Camarda was an astronaut that flew on Discovery's return to flight mission in 2005. He's pretty smart dude. He's a PhD. He's pretty smart. Yeah, check this out. Actually, NASA Spaceflight interviewed him a little while back about space. Pretty cool. So that's pretty good stuff. He's saying that the current Artemis heat shield is not safe. NASA does not understand the root cause, and it did not recreate the failure mechanism of Artemis 1 in the test. The current heat shield is dense/non-porous and will spall and crack in large chunks. Artemis 1's heat shield lost chunks prior to the skip entry, and NASA does not have a viable explanation. The same people on the analysis and test teams failed to speak up about the inadequacy of the impact analysis prior to the Columbia accident. Uh-oh. Do you guys remember when I said that, you remember when I said that? I said that. Like that, exactly. Yeah, that's not great. Yeah. I brought up that NASA is kind of willing to accept increased risk for Artemis 2 because they don't have any other way to test the heat shield. And that's true. They don't. Unless they, decided to put Orion on another rocket, which there's not, because we want to get to the moon, right? Where, they're not exploring these options because they would be too much of a delay. Should have kept with the original plan. Don't break what ain't broke. He told the same thing to Ellie in Space 1 to 2 months ago. Yeah, Black, I said this right when that Artemis 2 thing came out. When they delayed Artemis 2 to 2026 and then, tried to talk it up by saying, the reason for this delay is because we're going to fly when it's safe. Mutter, I know it's old. I know it's old. I know it gets old really, really quick, but also...
You sure about that? You sure about that? You sure about that?
Sure about that? Yeah, I didn't like that. I didn't like that press conference, and apparently there are other people that did not like it as well. You reminded me of the Fallout 4 Monsterfish? I don't know, not relevant. I just got done reading the book Bring Columbia Home. Yeah. It's very interesting that he'd bring this stuff up, because you know what, dude? I agree with him. I don't think that's a wise decision. I really think that schedule risk, lack of funding, which is a big one, that's huge. The lack of funding during the development cycle of the Artemis heat shield led to these cost-cutting decisions. And these cost-cutting decisions were not able to be adequately tested. I think that has a lot to do with it. So schedule risk and funding has really forced NASA's hand. And they're putting themselves in a position where they don't really have any choice but to accept like heightened risk. Meaning, we're pretty sure the heat shield will work on the next flight. But, there's no way to know until we go and do it. You don't really want to... Remember, I don't know if you guys remember, like, when we're watching, like, Crew 10 fly, and, when we watched Crew 9 come back down right after that, I did a whole thing during that bit about spaceflight, that what you do with spaceflight. You really want to understand how this stuff works. It's all about being preemptive, but it's knowing where and when to be preemptive about things. What does that mean? So, okay, people ask me, like, okay, what happens if they, they're actually, okay, what if you actually get stranded in space and you have no way home? Well, the best way, so that is very unlikely to happen. Because the best way to conduct yourself with spaceflight is to not put yourself in a position where that could happen. Okay? If you're not sure about your thrusters working and you're not sure about them, you actually like getting stranded in space, right? You shouldn't launch. Because if you're not sure, you don't fly. Fly when you're sure. I really don't understand why they didn't just glue one on the top of somebody's rocket and test it empty. Well, Lord Gugu, that's what I've been saying when I say Orion needs more testing. I don't mind them using the block heat shield. And when you go back and actually look at it, the engineering decisions that NASA's team have made to switch to a block heat shield instead of the original design, It's not the wrong decision. That's not the wrong decision at all. The lack of testing because of lack of funding is the big one. You want to know why these programs cost so freaking much? They end up costing crazy amounts is because they're not given adequate funding at the time to test. They got adequate funding over 10 years, but you don't need the same amount of funding over 10 years to run a space program. You know, you have to spend money during development, right? And then you spend a lot of money on development so you could spend less money during operations. We didn't see that because, you know, Orion is funded by the taxpayer. It's just been flat funded over the last 15 years, which is why we have these problems in the first place. So what do I mean by this? Yeah, Orion has plenty of money and it's seemingly very expensive. That price would have gone down if we had chosen to do 4 or 5 EFTs on Delta IV Heavy back in the day, 10 years ago. That would have been fine, because that would have gotten you adequate testing, so you wouldn't have to spend all this time trying to figure out if the stupid heat shield is going to work before the next flight. See what I'm saying? Okay, I already got that. But we know tech can fail regardless. Aircraft take off in fully serviceable conditions and develop issues during a flight all the time. No, they don't. There's always a root cause on capping. There's always a root cause. No, a perfectly good an airplane that's perfectly good flight condition that took off and had a problem isn't in perfectly good flight condition. Somebody screwed up. And if that's what you're trying to say, then yeah, I get it. You know, bird strikes or something notwithstanding, right? I know rockets are an entirely different ballgame, but you see my point. I really don't. I mean, maybe a little, but testing doesn't always equate to a trouble-free flight. Yeah, you're always going to learn something during a flight. I understand what you're saying there, but that's not with a component this big, dude. This is a mission critical component. It's not like Dragon, like, oh, the toilet doesn't work. Okay, we'll just pee in a bag instead. Like, it's not a big deal, right? The heat shield doesn't work, or has the potential to char, spall and crack in large chunks. That's a big difference, dude. An Orion launch on Vulcan or Falcon Heavy, sure, let's go. I think New Glenn would be the guy. Just saying. Apollo 13 was tested. No, it was not. Somebody dropped the oxygen tanks and didn't test them, Zubaski. It was not adequately tested. Long story short, you know, schedule risk and the not properly allocated funds are putting NASA into this position where they're accepting heightened risk when they really don't have to. I've said it once, I'll say it again. Putting people on the next Artemis missions on Artemis 2 is nuts. That's absolutely insane. You do not have a verified heat shield that works. That's crazy. That's dumb. That's like Jebediah Kerman levels of nuts. What's the solution to get more funding? Well, I'll talk to you when Isaacman gets confirmed. We'll see what happens. But yeah, it's cool to see that there are astronauts out at NASA. There are ex-astronauts that are kind of proving what I'm saying. Because I thought this was a crazy idea, and it's very clear that I'm not the only one. That makes me feel better, because that means my finger was on the pulse correctly here, I think. Not to toot my own horn, right? It's not about being right. It's about being a good teacher for you guys. That's really what matters to me the most. But it's good to see other an astronaut that actually has way more experience in this coming to the same conclusions. Because yeah, I don't think this is a good idea. I really don't. You schedule be damned, dude. You don't want another Apollo 1. You know, in this space race that we're having, because you know the schedule risk is that, you know, oh, China, you know, we're gonna be China there, we're gonna be China there. Yeah, we're gonna look really stupid if we kill 3 people while, you know, trying to beat them there. Badger, let you try and rephrase. In the case of Dragon last night, for example, did their test come back as okay on the ground? I would assume so. Why would they assume a failure is going to occur when no signs of failure were present during testing? I understand the heat shield is a big deal and people's lives depend on it, just trying to play devil's advocate. Their tests aren't coming back okay, Badger, because there's no way to test the heat shield down here. There's no way to test it. They're going off analysis only. The same analysis that said this heat shield would be fine on Artemis 1, and it absolutely wasn't. You have no way of proving it. You have no way of proving it. I get it. You have to accept some risk when anytime you're pushing the envelope of spaceflight. This has been done before. This has been done before 50 frigging years ago. Anyway, Baron, what are you saying? Orion's heat shield scares the heck out of you. Those char avulsion patterns and uneven ablation from Artemis 1 scream material inconsistency under re-entry plasma loads. Yeah. It's doing the same thing to the heat shield that Starship Flight 1 did to the Fondag pad. Yeah, it's doing the same thing. The production system variant they're using is solid in theory, but the unexpected erosion rates mean we're dealing with unpredictable heat flux distribution. And slapping a modified heat shield on Artemis 2 without a flight test is reckless. It's actually not modified. They're flying a different trajectory. That was the solution. You can't tweak a TPS for 25 megajoules per square meter energy dissipation and call it good. I agree. The analysis is butt. It's terrible. Because that same analysis said switching to a block heat shield would work, and it didn't. Sorry, so your thermal... Why would I believe you? Not you, you know what I mean? Yeah, Fluffy, yeah, that's what I mean. NASA's putting themselves in an extremely crappy position. It's not good, and I'm not concerned trolling, nor do I know better. But there are astronauts that have flown on the space shuttle that are experts in thermal protection system that are saying the same thing that I'm saying. So I might be, what I'm telling you is that I might be onto something here. You know, I might be onto something, maybe. Badger, maybe I'm being a bit thick, but if we know the heat shield they used during Apollo works, why try and fix something that ain't broken? Oh, they thought it was too complicated to make, Badger. So EFT-1, the Orion that flew in 2014, was a exact replica of an Apollo heat shield, and it worked great. It worked just fine. Then they decided it was too difficult to make, so they switched to a block heat shield, like what you would find from like Curiosity and Perseverance. They switched to that because that's what we have. That's we have experience building those heat shields. We don't have any experience building an Apollo-style heat shield because we haven't done it in 50 years. So they said switching to a block heat shield was easier to manufacture. Not only that, to be 100% fair, block heat shields are easier to test for quality assurance and control. The reason why is because you can actually take a heat shield block and look at the back of it and be like, okay, this is good, and put it back. The blocks fit together like Legos. I'll show you. See, this is what I'm talking about. See, these blocks fit together. It's a lot easier to QC these heat shields. The Apollo heat shield is one solid piece in this shape. You can't take it apart, and you don't know if your Avcode injection worked correctly until you fly it. So, once again, they switched to this because they don't have experience with the other way, but the other way is doesn't break during landing and re-entry. So pick one. Moreover, ground sims won't catch the chaotic boundary layer transitions we saw at Mach 30 plus. I've seen ablatives fail under less, and risking crew on an unproven fix feels like betting lives on a thermal conductivity hunch. It's awful analysis. Yeah, no, Baron, it's stupid. This is not a good idea. Yep. I wonder how much of it is because racing, how much because of yeah, I mean, they're in a really, really bad spot, NG. Did the shuttle astronauts basically say redesign the heat shield? In what context are you talking about? Because no, not really. Asking because I don't know. You're saying that NASA basically has a chance. Is NASA not the blame for this? Could they still be part of the problem if they don't protest, for lack of a better word, by refusing to fly A2 crew on the rocket or the mission at all? I think that's the part of what Charlie is talking about here. The same people on the analysis and test teams failed to speak up about the inadequacy of the impact analysis prior to the Columbia accident. Meaning the people that should be speaking up aren't. I wouldn't call the analysis stupid. They have data to ground their sims in from the previous flight, but trusting that analysis enough to fly people on it is stupid. Yeah, Jock, that's a nicer way of saying what I said. Yeah. What type of heat shield does Dragon use? Dragon uses a phenolic impregnated carbon ablator. It's basically like if you took acrylic and injected it into charcoal. It is a lot more complicated than that, but that's your material consistency. It's something similar to that. It's called pica. SpaceX has and it was a NASA design. For what it's worth. It's also a block shield. Yeah. It's built in chunks. It's easier to QC it. And that's what I mean. The NASA engineers are onto something with that. You can... With a block heat shield, it's much easier to... perform quality assurance on your stuff, to like make sure that it's going to work. You can be sure that it's going to work, and you can be sure that you're getting uniform consistency. The name of the game with a heat shield is to get the consistency in the block. The block has to have the same consistency as all the other blocks. If there's air bubbles in it, for instance, you're going to have a problem. That's why SpaceX doesn't have necessarily that problem, because theirs is injected with it's phenolic injected. So it displaces all of the air bubble that could be in there. The injection displaces the air bubbles. I'm pretty sure I got that right. If there's any TPS guys out there, I think that was a good enough way to explain that, but I'm not an expert on this. So yeah, Dragons, see, that Pica X is not tested for a trans-Earth injection. It's not tested for coming back to the moon. It's great for Dragon coming back from low Earth orbit. Orion's heat shield is great for coming from low Earth orbit too. The Avcoat will work just fine. What's really killing it is that when you're coming back from low Earth orbit, you hit the atmosphere, 19,000 miles an hour. When you're coming back from the moon, you hit it going 25,000 miles an hour. It's a little different. Swapping to a different re-entry trajectory for Artemis 2 doesn't dodge the core issues. Those cracks and ablation irregularities from Artemis 1 still stream inconsistent thermal response under load. A new trajectory might shift peak heating zones or alter stagnation point dynamics, potentially hitting untested stress limits of the already shaky material. We're still flying blind into a 5,000 degree Fahrenheit gamble. Yes, yeah, okay, we're on the same page there. I agree with you. So, stupid question, why can't they use Tough Rock heat shields on Orion? Dude, the entry speeds you could, Sawyer, you could redesign the heat shield again, but how much is that going to delay the program? Wouldn't casting in a vacuum work? I don't know, Creation. I don't know enough about how these things are put together. Jock, basically, you wouldn't blame the engineers doing the design and all. I bet those engineers would rather... What was that, Jock? Would rather have an uncrewed flight to see if it'll work before they have to be responsible for the astronauts. Yeah, Jock, I agree. I think the decision making, the more I talk about this and the more I learn about it, the more I read more about it, the engineering decision is sound. Switching to a block heat shield, I previously had said that's a really stupid idea. Switching to a block heat shield, why switch away from what works? Well, with the block heat shield, you can QA your heat shield. You can't do that with the way the Apollo program did it. The Apollo program was basically, okay, let's throw a ton of Avcoat here and make sure the heat shield, just throw as much Avcoat as you can, have it, and hopefully it's good. And they made up for that by just straight over engineering their heat shield, right? Which is smart because you know why? Because it worked. The block heat shields are easier to QC. It's easier to make sure that you're getting consistency per block. It's really easy to see if a block isn't materially consistent because it's in blocks. It's not in one big piece, right? So I actually agree with you on that one. The more I think about it, the more the engineering team at NASA, whoever's working on the heat shield at Lockheed for Orion, that's the right call. It is the right call. What isn't the right call is putting people on the next flight when you don't know if it's going to work or not. That's a stupid idea. I don't necessarily mind the block heat shield. Not a bad call. I used to think that was stupid. But I don't mind the engineering decisions made here. They're pretty good. They're pretty sound. But once again, you're risking people on the flight of an adjusted trajectory. You don't know conclusively if that heat shield is going to work. And remember what I said. The whole thing here is to make sure, like in spaceflight, the whole name of the game is to prevent yourself from being in a situation like this. You're not just engineering a spacecraft. You're engineering a spacecraft to make sure that you never enter these failure modes. You never have these funnies show up, these potentially mission-ending problem. That's really, really, really important in your analysis and development. You can't get this wrong. It has to be right. So what would be a fix? I have said, Grim, to put Orion, do a couple of uncrewed test flight missions with Orion in low Earth orbit, or shoot it off into high Earth orbit with like a Falcon Heavy or something, or New Glenn, or even Vulcan, something. You got to get more information on this heat shield and how it works. If doing a low Earth orbit isn't going to teach you much, but it will help you fill in the proverbial blanks, right? No, I mean hardware-wise, what is the fix? Artemis 3 is flying with a revised heat shield with the revised blocks, Grim. Artemis 2 is flying on a different trajectory with the same heat shield that broke during Artemis 1. Any redesign is the same problem as well. You cannot verify the design without flying it. Yeah, Jock, exactly. And this is what I mean when I said that. I used to think that, that's a stupid decision. No, it's not a stupid decision. The stupid decision was thinking that you'd fly this thing once or twice before putting people on it. That was the stupid decision. The stupid decision is a programmatic decision, which is what Charlie Camarda was talking about. It's a programmatic decision. Okay. All right. You want to get down to brass tacks? What I'm trying to tell you is that if we just kept going with Constellation, this wouldn't have happened. Okay, cool. Want to hear more crappy news? I got more crappy news for you. Here, it's a big spoonful of poop soup. Here you go. Open wide. Oh! Check this out. NASA did their due diligence by asking the industry for solutions. We did submit a plan like this for pusher redesign Avcode formulation with enhanced char stability, validated through ArcJet testing at 5500F to map ablation rates. Couple that with non-destructive evaluation, thinking something like X-ray tomography to catch microcracks pre-flight, ensuring uniformity, and then fly an uncrewed test flight. Yeah, that'd be good. All right, enjoy your poop soup. Here we go. It's a nice floater. So this is coming from Eric Berger, so take that for what it's worth. Starliner's flight to the space station was far wilder than most of us thought. So this is based off of an interview that Butch and Sonny did the other day. Oh. It all comes back to Ares 1. Getting rid of that Pasto under the guise of saving money was probably... That is probably the single most stupid decision that NASA has ever made, barring canceling Apollo. That was the dumbest. Anyway, as Starliner flew up towards the International Space Station last summer, the spacecraft lost 4 thrusters. NASA astronaut Butch Wilmore had to take manual control of the vehicle. But as Starliner's thrusters failed, Wilmore lost the ability to move the spacecraft in the direction he wanted to go. He and his fellow astronaut Sonny Williams knew where they wanted to go. Starliner had flown to within a stone's throw of the space station, a safe harbor. If only they could reach it. But already, the failure of so many thrusters violated the mission's flight rules. In such an instance, they were supposed to turn around and come back to Earth. Approaching the space station was deemed too risky for Wilmore and Williams aboard Starliner, as well as for the astronauts on the $100 billion space station. What if it was not safe to come home either? Quote, I don't know that we can come back to Earth at that point, Wilmore said in an interview. I don't know if we can. And a matter of fact, I'm thinking we probably can't. Starliner astronauts meet with the media. On Monday, for the first time since they returned to Earth on a Crew Dragon vehicle 2 weeks ago, Wilmore and Williams participated in a news conference at Johnson Space Center in Houston. Afterward, they spent hours conducting short 10-minute interviews with reporters from around the world describing their mission. I spoke with both of them, I being Eric Berger. Many of the questions concerned the politically messy end of the mission, in which the White House claimed that it had rescued the astronauts after they were stranded by the Biden administration. This was not true, but it's also not a question that active astronauts were going to answer. Correct. They have too much respect for the agency and the White House that appoints its leadership. Fair. They are trained not to speak out of school. As Wilmore said repeatedly on Monday, I can't speak to any of that, nor would I. Keep it classy. So when ours met with Wilmore at the end of the day, it was his final interview, scheduled for 4:55 to 5:05 in a small studio at Johnson Space Center. Politics was not on the menu. Instead, I wanted to know the real story, the heretofore untold story of what it was really like to fly Starliner. After all, the problems with the spacecraft's propulsion system precipitated all other events: the decision to fly Starliner home without crew, the reshuffling of the Crew 9 mission, and the recent return in March after 9 months in space. I've known Wilmore for a bit over a decade. I was privileged to see his launch on a Soyuz rocket from Kazakhstan in 2014 alongside its family. We are both about to become empty nesters with daughters who are seniors in high school, soon to go off to college. Perhaps because of this, Wilmore felt comfortable sharing his experiences and anxieties from the flight. We blew through the 10-minute interview slot and ended up talking for nearly half an hour. It's a hell of a story. Oh, dear. Oh, dear. All right. Launch in a cold night. Boeing Starliner spacecraft faced multiple delays before the vehicle's first crewed mission. Carrying NASA astronauts Butch Wilmore and Sonny Williams launched on June 5th, 2024. These included a faulty valve on the Atlas V rocket's upper stage, and then a helium leak inside the Starliner spacecraft. The valve issue in early May stood the mission down long enough that Wilmore asked to fly back to Houston for additional time in a flight simulator to keep his skills fresh. Finally, with fine weather, the Starliner crew flight test took off from Cape Canaveral, Florida. It marked the first human launch on an Atlas V rocket, which had a new Centaur upper stage with 2 engines. 2-engine Centaurs are not new. They have been flying since 1962 in various forms of Atlas rockets, might I add. But whatever. Semantics. Sunita Sonny Williams said this: "Oh man, the launch was awesome. Both of us looked at each other like, wow, this is going just perfectly. So the ride to space and the orbit insertion burn, all perfect. Butch said this: in simulations, there's always a little deviations in your trajectory. And during the launch on the shuttle on STS-129 many years ago in Soyuz, there's similar types of deviations that you see in the trajectory. I mean, it's always correcting back, but this ULA Atlas was dead on center. I mean, it was exactly in the crosshairs all the way. It was much different than what I had expected or experienced in the past. It was exhilarating. It was fantastic. Yeah, it really was. The dual-engine Centaur did have a surge. I'm not sure ULA knew about it, but it was obvious to us. We were the first to ride it. Initially, we asked, should it be doing that, the surging? But after a while, it was kind of soothing, and then again, we were flying right down the middle. After Starliner separated from the Atlas V rocket, Williams and Wilmore performed several maneuvering tests and put the vehicle through its paces. Starliner performed exceptionally well during these initial tests on day one. Wilmore, the precision, the ability to control the exact point that I wanted was great. There was very little, almost imperceptible cross control. I've never given a handling quality rating of 1, which was part of the measuring system. To take a qualitative test and make a quantitative assessment. I've never given a 1, ever, in any test I've ever done before, because nothing's ever deserved a 1. Boy, I was tempted in some of the tests that we did, but I didn't give it a 1. I didn't give it a 1, but it was pretty amazing. He's saying that the capsule, basically, the maneuvering systems on the capsule were really, they're really precise. Which is good. Following these tests, the crew attempted to sleep for several hours ahead of their all-important approach and docking with the International Space Station on the flight's second day. More so even than launch and landing, the most challenging part of the mission, which would stress Starliner's handling capabilities as well as its navigation system, would come up as it approached the orbiting laboratory. Williams, the night that we spent there in the spacecraft, it was a little chilly. We had traded off some of our clothes to bring up some equipment to the space station. I had the small t-shirt thing, long t-shirt, long t-shirt, and I was like, oh my gosh, I'm cold. Butch is like, I'm cold too. So I ended up actually putting our boots on, and then I put my spacesuit on. And he's like, maybe I want mine too. So actually both got in our spacesuits. Might just be because there were 2 people in there. Starliner was designed to fly 4 people to the International Space Station for 6-month stays on orbit. But for this initial test flight, there were just 2 people, which meant less body heat. Wilmer estimated that it was about 50 degrees in the cabin. It was definitely in the low 50s, if not cooler. When you're hustling and bustling and doing things, all the tests we were doing after lunch, we didn't notice it until we slowed down. Purposely didn't take sleeping bags. I was just going to bungee myself to the bulkhead. I had a sweatshirt and some sweatpants, and I thought, I'm gonna be fine. No, it was frigid. I even got inside my spacesuit, put the boots on and everything, the gloves, the whole thing, and it was still cold. Time to dock with the space station. After a few hours of fitful sleep, Wilmer decided to get up and start working to get his blood pumping. He reviewed the flight plan and knew it was going to be a big day. Wilmer had been concerned about the performance of the vehicle's reaction control system thrusters. There are 28 of them. Around the perimeter of Starliner's service module, at the aft of the vehicle, there are 4 doghouses equally spaced around the vehicle. That's those things right there, the thruster blocks. There's 4 of them. Each of these doghouses contains 7 small thrusters for maneuvering. In each doghouse, 2 thrusters are aft-facing and 2 thrusters are forward-facing. And 3 are in different radial directions. So there's some pointed this way, some pointed that way. There's one pointed straight up. Yeah. For docking, these thrusters are essential. There had been some problems with their performance during an uncrewed flight test to the space station in May of 2022, and Wilmer had been concerned those issues might crop up again. Before the flight, we had a meeting with a lot of the senior Boeing executives, including the chief engineer. This was Naveed Hussain, chief engineer for Boeing Defense, Space, and Security Division. Naveed asked me, what is my biggest concern? And I said the thrusters and the valves, because we'd have failures on the OFT missions. You don't get the hardware back. Yeah, this is on the service module of Starliner. They don't get those back. It jettisons the service module, and the heat shield for Starliner is right there. That silver stripe. So you're just looking at data and engineering judgment to say, okay, it must have been FOD, foreign object debris, or whatever the various issues they had. And I said, that's what concerns me the most, because in my mind, and I'm thinking, if we lost thrusters, we could be in a situation where we're in space and we can't control it. That's what I was thinking. And oh my, what happened? We lost the first You guys remember when I said a little bit earlier that space flight's about not putting yourself into situations like this? Well, there you go. This is why. It's dangerous. Someone could get really hurt. It's a miracle nobody did. When vehicles approach the space station, they use two imaginary lines to help guide their approach. These are the R bar, which is a line connecting the space station to the center of Earth. The R stands for radius. Radial. And then there's the V bar, which is the velocity vector of the space station. So if this is the ground, the ISS's orientation is pointed this way. The R bar is this way, and the V bar is that way. So the velocity vector and the radial vector. Okay? That is pretty much industry standard for like defining directions for a spacecraft. Spacecraft are floating around in space. They have 6 degrees of freedom. You have, forward and back, which is prograde, retrograde. You have left, right, which would be normal and anti-normal, right? And then you have up, down, or zenith and nadir, right? Which is radial out and radial in. So 6 degrees of freedom. So the V bar is the forward direction of the space station. The R bar would be a radial in. So this way, that's that direction. Because the ISS flies basically parallel to the ground. It flies like this around Earth. It uses a gigantic or quadruple redundant control moment gyros in the Z1 truss segment on top of the space station to basically turn the space station so it's basically looks like it's flying parallel to the ground. Well, not looks like, it is. They use gyros to do that. Due to the thruster issues, as Starliner neared the V-bar about 260 meters from the space station, Wilmore had to take manual control of the vehicle. So when a spacecraft comes up to the ISS, what it does is it basically gets out in front and then docks. Or it gets out in front, goes up to the top, and docks to the top of the station. This is a V-bar alignment docking. And this is an R-bar alignment docking. Starliner got out in front because they wanted it on the front port because it's easier to get to. The Dragon went to the front port on its first flight as well. Wilmore, as we got closer to the V-bar, we lose our second thruster. So now we're single fault tolerant for the loss of 6 degrees of freedom control. Yeah, that, I saw that I was reading that as I was talking. That's why I brought this up. You're single fault tolerant for 6 DOF, meaning, remember, prograde, retrograde, normal, anti-normal, radial out, radial in. Yeah. So fore, aft, left, right, zenith, nadir. You're down to one thruster for for loss of 6 degrees of freedom control. So one thruster is controlling one of those axes of movement. That's bad. Yeah, that's bad. That's how you LOC a spacecraft. That's not great. Yeah. Here's where things get a little more complicated if you never piloted it. Eric's going to explain it. Let's see how he explained it. When Wilmore refers to 6 DOF, he means 6 degrees of freedom. That is 6 degree different movements possible in three-dimensional space. Forward, back, up, down, left, right, yaw, pitch, and roll. Yep. Where Starliner's 4 doghouses and their various thrusters, a pilot is able to control the spacecraft's movement across 6 degrees of freedom. Yep. But as Starliner got within a few hundred meters of the space station, a second thruster failed. The condition of being single fault tolerant means that the vehicle could sustain just one more thruster failure before being at risk of losing full control of Starliner's movement. This would necessitate a mandatory abort of the docking attempt. Wilmore, we're single fault tolerant, and I'm thinking, wow, we're supposed to leave the space station because I know the flight rules. I did not know that the flight directors were already in discussions about waiving the flight rule because we've lost 2 thrusters. We didn't know why, they just dropped. Oh. Ugh. Heroes in Mission Control. As part of the Commercial Crew Program, 2 companies providing transportation services for NASA, SpaceX and Boeing got to decide who would fly their spacecraft. SpaceX chose to operate its Dragon vehicles out of a control center at the company's headquarters in Hawthorne, California. Boeing chose to contract with NASA's Mission Control at Johnson Space Center in Houston to fly Starliner. So at this point, the vehicle is under the purview of a flight director named Edvin Size. Size, I forget how to say Ed's last name. This was a capstone mission of his 15-year career as a NASA flight director. Thankfully, these folks are heroes, and please print this. What do heroes look like? Well, heroes put their tank on and run into a fiery building and pull people out of it. That's a hero. Heroes also sit at their cubicle for decades studying their systems and knowing their systems front to back. And when there is no time to assess a situation and go and talk to people and ask, what do you think? They know their systems so well that they can come up with a plan on the fly. That's a hero. There are several of them in Mission Control. ECOM, try SCE2 Auxiliary. From the outside, as Starliner approached the space station last June, we knew little of this. By following NASA's webcast of the docking, it was clear there were some thruster issues and that Wilmore had to take manual control, but we did not know that the final minutes before docking, NASA waived the flight rules about loss of thrusters. Does Starliner have reaction wheels? No. No. Control moment gyros aren't on as many things as you might think, Dan. Oh. According to Wilmore and Williams, the drama was only beginning at this point. We acquired the V-bar and I took manual control. Then we lose the third thruster. Now again, they're all in the same direction. And I'm picturing these thrusters that we're losing. We lost the 2 bottom thrusters. You can lose 4 thrusters. If they're top and bottom, but you still got 2 on the side, you can still maneuver. But if you lose the thrusters in off orthogonal, the bottom of the port, and you've got only starboard and the top, you can't control that. It's off axis. So I'm parsing all this out in my mind because I understand the system. And we lose 2 of the bottom thrusters. We lost a port thruster, and now we're 0 fault tolerant. Holy... That... Dude. That's bad. Oh... How the hell did you dock that thing? Holy crap. We're already past the point where we're supposed to leave, and now we're 0 fault tolerant and I'm in manual control. And oh my, the control is sluggish. Compared to the first day, it's just not the same spacecraft. That's because the thruster's overheated. When they overheat, they start to leak, so you get fuel leaking around in places that aren't the rocket engine. Not great. Am I able to maintain control? I am, but it's not the same. At this point in the interview, Wilmore went into some wonderful detail. Yes, Gwen, pretty much. This is a nightmare. This is bad. This is not like Apollo 13. Oh, somebody dropped it and we fixed it. This is just sloppy engineering. Like, big red flag. Big red flag. Like, do not fly a person on this thing. Like, yeah, that's bad. And this is the part I'm sure you haven't heard. We lost the fourth thruster. Now we've lost 6 degrees of freedom control. We can't maneuver forward. I still have control, supposedly, on all other axes. But I'm thinking, the F-18 is fly-by-wire. You put control into the stick and the throttle, and it sends the signal to the computer. Computer goes, okay, he wants to do that. Let's throw out that aileron a bit. Let's throw that stabilizer a bit. Let's pull the rudder there. And it's going to maintain balanced flight. I've not even had a reason to think, how does Starliner do this to maintain a balance? I'll get more into that in a second, Orange, yeah. This is a very precarious situation we're in. Essentially, Wilmore could not fully control Starliner any longer, but simply abandoning the docking attempt was not a palatable solution. Yep. Just as the thrusters were needed to control the vehicle during the docking process, they were also necessary to position Starliner for its deorbit burn and re-entry to Earth's atmosphere. So Wilmore had to contemplate whether it was riskier to approach the space station or to try flying back to Earth. Williams was worried about the same thing. There was a lot of unsaid communication, like, hey, this is a very precarious situation we're in. I think both of us overwhelmingly felt like it would be really nice to dock to the space station that's right in front of us. We knew that they, Mission Control, were working really hard to be able to keep communication with us, and they're able to send us commands. We were both thinking, if we lose communication with the ground, so Nordo concept of operations, this means flying a vehicle without a radio. And we didn't talk about it too much, but we already had synced in our minds that we should go to the space station. Yeah, in this particular scenario, guys, that is absolutely the right call. Oh yeah, absolutely the right call. You're not sure if the thrusters are going to be able to take you home. The space station's right there. Get to the space station, figure it out later. 9 months later. But that's better than actually being stranded in space. That's the right call. That is absolutely the right move. This is our place that we need to probably go to have a conversation, because we don't know exactly what is happening, why the thrusters are falling off, and what the solution would be. Wilmer, I don't know that we can come back to Earth at that point. I don't know if we can. And a matter of fact, I'm thinking we probably can't. So there we are, loss of 6 degrees of freedom control, 4 aft thrusters down. And I'm visualizing orbital mechanics. The space station is nose down. So we're not exactly level with the station, but we're kind of below it. If you're below the station, you're moving faster. That's orbital mechanics. That's right. That's right. It's going to make you move away from the space station. So I'm doing all of this in my mind. I don't know what control I have. What if I lose another thruster? What if we lose communications? What am I going to do? Holy dude. This Barry Wilmore is a national treasure. How the frick did he get that capsule to that space station, dude? Oh my god. Yo, put this guy on the next flight, or not, maybe not Artemis 2. Put this guy on a flight to the moon. Holy crap. This is the kind of this is the kind of guy you want flying a lunar lander. You know what I'm saying? That's nuts, dude. One of the other challenges at this point, in addition to holding his position relative to the space station, was keeping Starliner's nose pointed directly at the orbiting laboratory. Yep, Starliner is based on a vision system that looks at the space station and uses the space station as a frame of reference. Yeah, it's called Vesta. It's using a relative navigation system. Actually, quite similar to like Tesla full self-driving. It's very similar to Tesla FSD. Or, if we want to talk rockets, the relative navigation system on like Intuitive Machines Lander and Blue Ghost. So if we had started to fall off and lose that, which there's a plus or minus that we can have, if we started to fall off and lose that, which is a plus or minus that we can have, we didn't lose the station ever, but we did start to deviate a little bit. I think both of us were getting a bit nervous then because the system would have automatically aborted us. Dude who made Tesla FSD made Vesta. Yeah, After Starliner lost 4 of its 28 reaction control system thrusters, Van Cise and the team in Houston decided the best chance for success was resetting the failed thrusters. This is effectively a fancy way of turning off your computer and rebooting it to try and solve the problem. But it meant Wilmore had to go hands-off from Starliner's controls. Oh my goodness. Oh my goodness. This is... Okay. Imagine that. You're drifting away from the space station, trying to maintain your position. Station is your only real lifeline because if you lose the ability to dock, the chance of coming back in one piece is quite low. And now you're being told you take the hands off the controls. Yep. Oh my gosh. Okay, so Wilmore. This is not easy to do. I've lived rendezvous orbital dynamics going back decades. Wilmore was only one of 2 active NASA astronauts who experienced piloting the space shuttle. Ray Biganese is our rendezvous officer. What a motivated individual. Primarily him, but me as well. We worked to develop this manual rendezvous capability over the years. He's a volunteer fireman, and he said, "Hey, I'm coming off shift at 5:30 Saturday morning. Will you meet me in the sim?" So, we'd meet on Saturdays. We never got to the point of, say, losing 4 thrusters. Who would have thought that, but in the same direction? Yeah, exactly. That's a weird failure mode. But we're in there training, doing things, playing around. That was preparation. All this training meant Wilmore felt like he was in the best position to fly Starliner, and he did not relish the thought of giving up control. But finally, when he thought the spacecraft was temporarily stable enough, Wilmore called down to mission control and called hands off almost immediately. Hands off. Almost immediately, flight controllers sent a signal to override Starliner's flight computer and fire the thrusters that had been turned off. 2 of the 4 thrusters came back online. Oh my God. Have I ever watched the Martian movie? Yeah, of course. Wilmore. Now we're back to single fault tolerant. But then we lose a 5th jet. Oh my God. What if we had lost that 5th jet while those other 4 were still down? I have no idea what would have happened. I attribute to the providence of the Lord getting those 2 jets back before the 5th one failed. Yeah. 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 Yeah, dude. Oh my goodness. So we're down to 0 fault tolerant again. I could still maintain control. Again, sluggish. Not only was the control different on the visual, what inputs and what it looked like, but we could hear it. The valve opening and closing, when a thruster would fire, it was like a machine gun. Ugh. It's not a wiring issue, Creation. The thrusters are overheating. Because the pulse width modulation on your thrusters was not good. It was not good enough due to crappy, frankly atrocious thermal analysis. Yeah. Yeah, that's what we know. We know that happened. That's what the press conference after this happened. We watched it on stream, and I was like, okay, that's good. We're probably not flying home in Starliner. Mission Control decided that it wanted to try and recover the failed thrusters again. After Wilmore took his hands off the controls, this process recovered all but 1 of them. At that point, the vehicle could be flown autonomously, as it was intended to be. When asked to give up control of the vehicle for its final approach to the station, Wilmore said he was apprehensive about doing so. He was concerned that if the system went into automation mode, it may not have been possible to get it back in manual mode. After all that had happened, he wanted to make sure he could take control of Starliner again. Dolphins. I was very apprehensive. In earlier simulations, I'd even told the flight directors, if we get in a situation where I got to give it back to auto, I may not do it. And they understood. But if I've got into a mode that's working, I don't want to give it up. Yep. But because we got those jets back, I thought, okay, we're only down one. All this is going through my mind in real time. And I gave it back, and of course we docked. Williams, I was super happy. Sonny's saying this. I was super happy. If you remember from the video, when we came into the space station, I did this little happy dance. One, of course, just because I love being in space, and I'm happy to be on the space station with great friends up there. Two, just really happy that Starliner docked to the space station. My feeling at that point in time was like, oh, phew. Let's just take a breather and try to understand what happened. Oh my God. There are really great people on our team. Our team is huge. The commercial crew program, NASA and Boeing engineers, we're all working hard to try and understand, to try and decide what we might need to do to get us to come back in that spacecraft. At that point, we also knew it was going to take a little while. Everything in this business takes a little while. Like, you know, because you want to cross the T's and dot the I's and make sure. I think the decision at the end of the summer was the right decision. We didn't have all the T's crossed. We didn't have all the I's dotted. So do we take that risk where we don't need to? Hell no. 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 That was the right move. That was always the right move. Wilmore added that he felt pretty confident in the aftermath of docking to the space station that Starliner probably would not be their ride home. He said, I was thinking we might not come home in that spacecraft. We might not. And one of the first phone calls I made was to Vincent Lecourt, the ISS flight director, who was one of the ones that made the call about waiving the flight rule. I said, okay, what about this spacecraft? Is it our safe haven? It was unlikely to happen, but if some catastrophic space station emergency occurred while Wilmore and Williams were on orbit, what were they supposed to do? Should they retreat to Starliner for an emergency departure, or cram into one of the other vehicles on the station, for which they did not have any seats or spacesuits? Lecourt said they should use Starliner as a safe haven for the time being. Therein followed a long series of meetings and discussion about Starliner's sustainability for flying crew back to Earth. Publicly, NASA and Boeing expressed confidence in Starliner's safe return with the crew. But Williams and Wilmore just made that harrowing ride felt differently. Wilmore, I was very skeptical just because of what we'd experienced. I just didn't see that we could make it. I was hopeful that we could, but it would have been really tough to get there to where we could say, yeah, we can come back. So they did not. That was good. That was a good article from Eric, man. That was pretty good, dude. I must say, credit where credit is due. Oh my goodness. What a nightmare. That is why you don't accept heightened risk in spaceflight. Right there. That easily could have gone south. Like, 1 minute you think you're totally good, the next minute your mission failed. Like, it can happen very quickly. What a piece of junk. Yeah. Yep. That was some Apollo 13 stuff. Yeah, flight controllers, man. Flight ops doesn't get enough credit. Doesn't get enough credit, Tessa, for what those people do. Wow. Side note, the capsule made it back home fine, but still the right call not to risk the loss. You don't do it if you don't know. Right, Lumbo? That's what I've been trying to teach everybody. Don't do it if you do not know. Most mission failures are sudden and unforeseen. That's right. It's usually because of a cascading failure, like that. Between the lines, I get the impression that Williams was not going to accept any decision that wanted them to return on Starliner regardless of how Boeing felt. They're the test pilots. If the test pilot's saying, I'm not flying in that, you should probably rethink it. The context there is that test pilots are supposed to fly in something that is a proverbial death trap to figure out if it actually is a death trap or not. That's the whole point of a test pilot. Capsule lost its thruster in the capsule section on the way home, by the way. Yeah, do we know that for sure, Baron? Like, I'm not going to go around spouting that if it's not an official source. We were a lot closer to losing that crew than I had any idea. Yeah. Once the yellow or the red flags start popping up like that, dude. Scary. Scary. That's ballsy. That's you have a choice between failing thrusters and something, and the toilet not working. Yeah, there you go. Can I get a link to that article? Only caught half. It's a great article. I'll link it up, guys. I'm actually very impressed with Eric. That's pretty good, man. Pretty good. Very impressed. That was a good article, dude. I get you saying flight controllers, but who on the ground wanted to change the rules last minute? The flight controllers. LaCourte. Yeah, Viper, I got it. Thank you, though. I'd like to hear those loops during that time. I bet they were interesting. Dude, I knew something was funky with that capsule, David. I would like to... I'd be curious to go and watch the Starliner. My coverage of Starliner again. I'd have to go find the VOD. I'd be curious to see it. I very, 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 very much recall something very bad. Like the capsule just sitting there and kind of like them not going right for docking and stuff. Like I was like, something ain't right here. And I remember the press conference where they're like, yeah, we blew out thrusters, and I'm sitting there going, okay, that's great. With this out, does this kill Starliner? No. No. Based on that, unless they can guarantee that those thrusters are fixed, I don't think the rest of the Starliners will be carrying anything except cargo. So, guys, let me give you a little bit of context. Here's the conundrum that the Starliner program is in right now. Okay, long story short, this mission, the OFT, this OFT or CFT mission, this crew flight test that Barry and Sonny flew, okay? This was supposed to validate the capsule. It's supposed to be an end-to-end test with people on board to prove that the capsule is safe. Obviously, that did not work. That did not do what you thought, right? That didn't happen. But that didn't happen here. This capsule had positive traction. Can't make these mocks without positive traction. Sorry, suddenly my cousin Vinny. So obviously that didn't happen here. So Boeing and NASA are in a very interesting spot. Okay. So on one hand, you have to verify you're going to fly. This thing can fly and you won't blow out a thruster. Okay. Whoever made the decision at Boeing to fly people on this thing, when the uncrewed flight test that precluded it blew out thrusters, whoever made the decision to fly people on it after that is not the sharpest tool in the shed. That was an incredibly stupid thing to do. I can't say that I would have done better. Hindsight is 2020. Okay? It's very easy to point out mistakes in spaceflight after somebody has basically spoon-fed you the failure modes. It's very easy. It takes skill to spot it before it happens. That's what separates us who speculate about launches from actual engineers. Now, you got to verify that those thrusters are working. There's no way to test that down here because the thrusters failed in a vacuum. They failed up there. That's when they started overheating. So how are the thrusters overheating? The thrusters that Starliner uses have a passive cooling system. It is a rocket engine. The thrusters, the little things that are used for fine control and movement, are still rocket engines. They just don't necessarily work like rocket engines, so to speak. They're pressure-fed hypergolics. So the rocket engine consists of, it's a de Laval convergent divergent nozzle. It looks like a rocket engine. It's just about this big. The throat of the nozzle's maybe the diameter of a golf ball at best, right? It's a tiny little rocket engine. And at the top of the rocket engine, you have two injectors. One is for your liquid fuel, one is for your oxidizer. Those are pressure fed into the system, right? And when those two chemicals, nitrogen tetroxide is your oxidizer and monomethyl hydrazine, when they get sprayed into the combustion chamber, when they chemically combine, they explode. It's called a hypergolic propellant. All right. So you have your NTO and you have your MMH thruster. Those shoot into the combustion chamber, right? They pop, right? And the rocket engine does rocket engine things. You know, the thing about RCS and reaction control system thrusters, attitude control system thrusters, whatever. The thing about it is that it's not constantly firing. Why? It's not like a rocket engine that turns on and, no. That's not how RCS works. First and foremost, due to the nature of hypergolic, well, it's not actually due to the nature of hypergolic propellants. The big thing, and I'll just cut straight to the chase here. There's a lot of things, but the big thing is introducing too much heat into the engine. Unlike a Raptor engine or a shuttle engine that use cryogenic propellants to cool the nozzle to keep it from melting, right? Reaction control system thrusters don't do that. They actually rely on a nozzle. They rely on material science to keep themselves cool, long story short. Not in the same way that you'd use cold propellants to exchange gases to keep your nozzle cool. What these things do is they're made out of niobium. They're made out of a very, very particular composite of, alloy of metal that glows. It's basically, if you introduce heat to it, it glows really, really easily. Now, I know you guys have always all seen when metal heats up, it glows different colors, right? And then it melts, right? The metal on these thrusters is designed to glow very, very bright. Why? That's your cooling system. You're not going to be able to shed the heat in the vacuum that's introduced from combustion of your hypergolic propellants. You're not going to be able to shed the heat. You're not doing it with convection. Okay, there's no atmosphere. Down here, like a car engine, an internal combustion engine, for instance, is exchanging the heat that's generated from combustion with coolant that's going through a radiator, and that radiator is taking in air at high speed to cool the coolant and keep the engine from melting, right? An engine without a radiator is going to melt. You'll introduce too much heat. It can't convect the heat out fast enough. Water can carry or coolant can carry the heat to do that, right? You can't do that with an RCS thruster. You can't do that. So they rely on the metal glowing. Now, what does the glowing metal do? Well, it radiates heat. All right? And when I say radiate, I mean in the very literal sense of the term. They use black body radiation or infrared to shed the heat from these thrusters. The thrusters glow, right? Now, that only happens at a certain rate. Right, the thruster will shed it. It can only shed at a certain rate. You don't have control over the rate of which you cool. Right? Now, what you do have control of is the rate at which you spray fuel into said thruster. You do have control over that. That's called pulse width modulation in spaceflight terms. Because you have two injectors at the top of the engine, right? And each one is spraying the fuel in. These are and they're pressure fed, so there's pressure behind them. So it's a pressurized system, like a fuel injection system on a car, if you're familiar with that. And those things, they click on and off. Now, the rate at which they click on and off, your pulsing rate for spraying fuel and basically turning on the thruster, right, is entirely dependent on how quickly that thruster can radiate the heat. Because remember what I said about heating up metal. You take something metallic and you put a blowtorch to it, it'll heat up, it'll glow, and then what happens after you introduce too much heat into it? You'll introduce phase change. Which is exactly what happened. The thrusters, they were blowing out, the computer was disabling thrusters because they were introducing way too much heat into said thrusters. A proverbial rev limiter for your control systems, which is, frankly, credit where credit is due, that is a very, very, very well-made control system from Boeing. Like, I will say, credit where credit is due, the control system did its job. That is exactly what it's supposed to do. It's supposed to shut off the thruster before you start breaking things. Because what happens if you introduce too much heat into that thing? Well, we already said you can't convect it because there's no atmosphere because you're in the vacuum of space, right? You can't radiate it because the engine's already glowing. You only have a certain rate of flux for heat here through the nozzle. You can only radiate so much because the metal can only move that heat out at a certain rate. You're limited by material science there, so you're not radiating and you're not convecting. So what's the last one? The last method of thermal transfer here is conduction. All right? Meaning if you're touching it, you'll absorb some of the heat. Remember, go back to that car analogy that we were talking about. What does that coolant do? The coolant flows through the warm engine and pulls the heat from the metal and puts it into the radiator, which gets cooled by the air, right? Water is really good at doing that. You can't have water here. So there's no water. Remember, these things only have the passive control system. It's only how much the nozzle can glow. So now the rest of the doghouse is conducting heat. And before the control systems could shut it off, it started damaging some parts of the thrusters. Some of the injectors on your thrusters started getting too hot and they started melting. Not great. Not cool. That's not good. That's not a good thing. So, okay, why am I telling you all this? Well, okay, so that's the first problem. You cannot test those thrusters down here. You can't test them in the vacuum. We don't have a vacuum chamber that's designed to handle outgassing like that. Because if you're in a vacuum chamber and you have a service module that's shooting off its thrusters, you're going to pressurize the vacuum chamber, right? We don't have a way to test that down here. Could we build a test stand for it? Yeah, sure. That'd probably be a good idea. Just saying. Probably be a good idea. That's easy to say in hindsight. Once again, it's easy to have this all laid out for you. The other way to do it is to fly it again. Now, you're not going to fly. Do you want to fly this again with people on it? No. You're not going to go for a certification unless you're absolutely sure, unlike what happened the first time. So Boeing is in this very interesting spot. They need to get certification so they can fly crew to the ISS. But you're not sure if the thrusters work. And you have to do a flight test to make sure your thrusters work. If you want to be absolutely sure that people can fly up and down on this thing. The uphill ride and the downhill ride you need an end-to-end demonstration of the capsule to get human rating certification from NASA. So, you see the problem that they have here? Chicken or the egg? Which one do you do? This is the predicament that Boeing is in right now. I don't think it's going to be... Sorry, that was a really long response. I apologize. I needed to bring everybody up to speed. Do I think this is doomed for the Starliner program? No. But they are in a little bit of a pickle. Which one do you do? You can't just fly Starliner on another vehicle. I mean, maybe they could. But you got to remember, the vehicle that it's designed to fly on, Atlas V, you only have 6 of those left. Atlas V isn't produced anymore. You can't buy any more engines for that thing, for the first stage particularly. You know why? The first stage engines are made in Russia. Whoops. So we're not getting any more of those. You only have 6 Atlas V left for Starliner, and you're on the hook for 6 missions for NASA. See what I mean? They're in a really weird spot here. Oh, Tessa, thank you for linking that up. I appreciate it. Yeah, I'll go look. Yeah, also the guy that was running the Starliner program stepped down. Yeah, he stepped down before Butch and Sonny came home. Crazy, right? Captain Crash, as a pilot, I was thinking about how many backup plans I have ready at my disposal. Imagine how it felt to watch their contingency plans go to -1, as in a lock situation. A lock situation next to the ISS. Dude, it does not get any more white knuckle than that. You want a thrill? That is a hell of a failure mode. I can't believe Barry got that capsule to the space station, man. I cannot believe that is ridiculous. Give that guy a raise, dude. Give that dude a raise. David, isn't NASA talking about certifying crew without another test flight? And David, just like Orion, flying people on Orion's next flight, if you're not 100% sure if that heat shield works, just like that is a red flag, this is another big red flag. Big one. Hell no. No, absolutely not. I would rather fly 4 crews to the ISS, right? And use 2 of those Atlas out of the 6 that you have, right? Fly 4 crews to the ISS on routine crew rotations. The next Starliner capsule flies uncrewed to test those thrusters on a cargo mission. And then the one after that is its certification flight, and then fly 4 missions to the ISS and be done with it. That is the safest way forward. And I don't mean safe like perception of safety. That, I can't be any more candid than this. That's the best way to go forward without killing someone. Yeah, we don't want to do that. That would be bad. Dude, I'd be rich as heck because of how many diamonds I would have made if I were in the position. Dude, the fact that he's just like, this is unfortunate. How am I going to fix this? It's like, dude, you were like an inch from death. Oh my goodness. Will Isaacman undo all this stuff? Yeah, Fluffy, I'm not sure. How heavy is Starliner? I'm not, Lumbo, I don't have that off the top of my head. There are Atlases booked for Kuiper launches that Boeing could possibly negotiate moving on to Vulcan. That's possible, Gwen. There are contingencies, but Boeing is in a very interesting spot. But see, you got the people that you sent up there, you got home. That's fine. You dodged a bullet here. You gotta... This is what happens when you don't cross your T's and dot your I's, as Barry said. This is what happens when you don't do this. This is what happens when you, like, okay, it's good. It's fine. When you're not running a tight ship. It is so important with space flight. Because, like I said, it can go south so fast, dude. It can go south so quickly. It's ridiculous. I said this after the press conference after Butch and Sonny docked, where I heard that the thermal model was wrong. How was your thermal model wrong? OFD2 was supposed to validate it. And it didn't. And you still said it was okay. That's bad. That's really bad. Like, I don't mean to be candid. That's a colossal screw up. Like, colossally bad. Tessa, you got the VOD for Starliner when it goes into the docking sequence. I'd be very curious to see. I want to see what my reaction to this was. Did I see if something was wrong? Let me see. I'm going to go over here. No fly zone.
And confirmation we have entered
ISS.
the approach ellipsoid.
So there's the approach ellipsoid and then the keep out sphere, and then the keep out sphere right after that. Yeah. Okay. ISS. So right now he said they did V-bar alignment, Tessa. So we got to go. So per this diagram here, your V-bar alignment is up there. Right. This is showing the differential eccentricity and what the path of the differential eccentricity would be relative to the space station. That's the space station. That's the V-bar alignment corridor. That's V-bar alignment over there that Barry was talking about. This week. Why do I keep moving from side to side, dang it? Starlink launches, Starliner, CFT. Okay, they're still in V-bar alignment there. See that it pulsed the thrusters there, and now it's moving to V-bar alignment. That's in this box right here. If you notice, on the left graphic, it kind of looks like Pac-Man. There's a red V.
Whack, whack,
That
whack,
is
whack,
the
whack, whack,
V-bar
whack, whack, whack.
approach corridor. Yeah, that's me saying the same stuff. That's pretty cool.
That burn happening right on time, 10:07 a.m. Central Time.
IF2 burn and Butch, say again for data flashing on orb dredge.
The nav flare, the white converged, and then 4.02, then inbound fly around, and then the destination A and B in the ARD region. Not all flashing at the same time. Different ones would flash at different
Yeah,
times.
so right.
But there was still a lot of flashing.
I'm happy you got here when you did.
Okay. Yeah,
enjoy your
that was my
company.
next question.
I missed that. Yeah, there you go. Well, insane.
Yeah, and good report. Thanks, Butch. We'll have to take a look at that one. And Starliner, we're curious, with that flashing on the parameters, are you comfortable enough that you can command a destination A or B?
Yes, now it's not doing it. I could have done it before as well. Where you actually do the commands, it was fine. Like the abort and the recover, those type of flashes. It's just the white text. And the reason I called you, I know it was right before the burn, because I was hoping to call your attention to it in case it was still doing it and you could see it. So my apologies.
Yeah, no, appreciate it. Sorry, we just didn't copy the whole transmission right before the burn.
What's on tap for next week? Yeah. So I was watching. I was wondering if I saw that the thrusters weren't working with Starliner, because we realized that as we were watching this is the CFT1 docking coverage from a little while back, right? This is when Starliner went up to the space station, right? As this was going on, they were blowing out thrusters left and right. I picked up on it, but I guess I didn't see it pertinent to say something. We want more, 7, right? We want more. Please launch again. We got a Starlink tomorrow. Does that help? Guys, this wasn't that long ago. This is SkyTouch. That's right. Less than a year ago. Elon saying IFT5 catch. To be honest with you, I don't think catching the booster is as crazy as everybody makes it out to be.
With completion of the IF2
SpaceX
burn,
has a pretty
that's
good
the
idea.
inbound fly around 2 burn, we are now looking toward the ACI burn in 12.
Hey, credit where credit is due. Pass DJ, baby. All right. You missing what's going on the stream, though, idiot?
minutes. That's the approach corridor initiation. So at that point, the Starliner spacecraft will be about 300 meters in front of the International Space Station, directly in front of the Node 2 forward docking port where we are headed today. Once we get to the 260-meter mark, the crew will take manual control of the spacecraft and do another manual piloting demo. This time looks like we will have good visuals from the space station to see it. We've now stepped into a satellite handover. The space station uses tracking and data relay satellite systems, and we periodically experience these handovers as we switch from one satellite to the next. But these are tracked and, as you can see, usually very quickly regained.
Yeah, right. Right, Red? Yeah, we just kind of brute force it up to the station. Gerbil. Hey, Red Munchkin, how you doing? Did that flap burn? I can't believe that flap stayed together. Can you believe that? What? This must have been like right after Ship 29 made it through.
I think it's RCS jet residue on the window, outside the window.
Okay.
Yep.
Yeah, Butch, we're assuming you're talking out the IVA hatch window for the centerline camera.
That's affirmative. I mean, all of our windows had it. It's pretty much covered, but yeah, that one, it's not objectionable. I'm just letting you know it's there.
No, John.
Okay, copy.
Yeah, Dean, that sounds right. It's a shot from the ISS looking at Starliner as Starliner gets lined up for the approach corridor initiation, or ACI burn. Nice. Very knowledgeable, that guy. Nice, Blue. Yeah, someone's posted that already. I think Bright Shiny posted that. Ah, Bright Shiny. What's up, dude? He's here. At least I think he is. Space seems really busy the last 48 hours. Yep, Noswell, I think I've gotten cumulatively probably about 8 hours of sleep in the last 48. Yeah. Nice. Your boy's running on fumes. Basically, okay, all right. Oh, that's not good for you. Going to crash. Yeah, Andromeda. This guy knows what's up. This guy knows some maneuvers. It's gonna be like hypnotized, like, you know. I don't think caffeine's gonna fix this, guys. I haven't slept in a really long time.
And Starliner continuing its
I don't think
slow
caffeine can
approach
fix it.
as it gets near the box to start the ACI burn.
Let's watch the docking and play it by ear, Alleviate.
51 meters away from the Node 2 forward docking port. Currently approaching at about 0.22 meters per second.
Program that says you said they have the data from SpaceX has the data from Super Heavy now. They just need multiple towers before the catch attempt. Sure about that? Yeah. Vivian, hey, thank you for the streams and coverage. Oh, absolutely, my pleasure. I wouldn't miss this for the world. Hey, Pete, 41-month resub. Hey, dude, 25 mission. How many times Starliner's orbited the Earth already? All right, let's get to 428. Tesla, you said that's when stuff really starts getting weird. Every one of them does. We just don't hear about it from time to time.
However, it is.
They would. Same thing as if a plane slides off a runway, Alleviate. You generally don't want that. You want to make sure you're prepared as possible. It's crazy because you look like two different people. What are you talking about? Let me put it to you like this: they wouldn't have the capsule there if they weren't confident that it will nail the approach. You know? Ooh, that statement aged very poorly. Oh. Oh, did you hear what I just said? Oh, boy. Oh, that statement aged very poorly. You're prepared as possible.
Today, however, it is.
They would, let me put it to you like this. They wouldn't have the capsule there if they weren't confident that it will nail the approach. You know what I mean? Even with all the helium leaks. Guys, once again, everybody's like, oh, Starliner leaks helium, Starliner. Every craft leaks helium, guys. That's very true. It does, but not like, but blowing out thrusters is another thing. I hate to break it to you. Every one of them does. We just don't hear about it from time to time. Every single spacecraft leaks helium in one way or another. That's correct. And it's better to catch these problems now. Every new spacecraft is going to have teething problems. It happens. I keep refreshing Twitter hoping for Starship images. Yeah. Henris, I don't blame you, to be honest.
160 meters. Bushes are going to begin the...
Like, I hate to be that guy, you know, but I see people trying to frame this to, you know, like as like how Starliner is some like bad spacecraft or something. Well, if it was a bad spacecraft, it wouldn't be 260 meters from the International Space Station right now. Let me... Yeah, I was wrong. Yep, that was wrong. That was very wrong. that was a very wrong thing to say. Blame it on lack of sleep. Yeah, well, yeah. Holy crap. That is very inaccurate. Put it to you like that.
Guys, every spacecraft leaks helium. The Apollo service module did.
That is right. They leak helium, but what those other see, we have the context here. Other spacecraft don't blow out thrusters, except the space shuttle. The space shuttle did blow out thrusters, and guess where Starliner's thrusters are derived from. They're derived from the space shuttle. Whoops.
Complicated RCS than most capsules. Dragon leaks helium, sure.
It does. That's correct.
You know, Steve Stitch, the guy that runs the commercial crew program, the guy that's on the NASA side of things that oversees everything for Dragon and Starliner, acknowledged this in a press conference actually recently. Dragon's leaked helium in the past. It's happened. We just didn't hear about it. Starliner does it. Now, Shuttle does it. Everything's done it at some point. Now, once again, Dragon did it in the past. That doesn't mean it's doing it right now. But that's what I mean about teething problems with spaceships. It happens. It happens.
Not like this. Not like this. No. Not like this. See, that's what I mean. It's easy to see the problems in hindsight. They make perfect sense in hindsight. It's very difficult to see them as they're happening. Now, I'm sitting there talking about how Starliner's fine, and Barry Wilmore has lost control of it. And he said that there were lights everywhere and I didn't notice. Do you leak helium? No. This was after Flight 4. Yep. I was right about Starship, though. Yeah, baby.
It's what I was saying, you know, Hannah, you and I were talking about it. It's what I was saying before. No mission has 100% success. If you were 100% successful, your analysis was wrong. You know why?
Oh, that's a right statement. Hey, all right. Yeah, that was right. Yep. Everything's going fine here with this mission, huh? Hey, all right. Hey, all right. Nice. Whoops.
Because spaceflight is like Tetris, okay? You don't really win, you just get better at it every time you try.
Yeah, and if you try it more, you get better at it as a overall net gain, which is why SpaceX sends people to the space station and Boeing does not at this point in time.
You know, and I know there's that kid actually on Twitch that beat Tetris basically until Tetris mem leaked itself and crashed. That I don't know if that counts as beating Tetris, but yeah, you never win at spaceflight. You never get 100%. That never happens. Ever. You're always going to have something weird going wrong. The question is, how prepared are you for when that does eventually happen?
And the business call this foreshadowing. Well, that was an ironic time to say that. In hindsight, that was a very ironic time considering the capsule's drifting away from the space station with a loss of control at this exact moment. Are you arguing with yourself? No, I'm trying to see if I noticed that Starliner was having problems when it originally docked to the space station, Bart. I didn't really notice, but I was close. Some things I was dead wrong on. Like, I was like, oh yeah, if it was good, it wouldn't be near the space station. Nope. We later learned that at this particular moment in time, the Butch and Sonny do not have control of that vehicle. At this exact moment. Yep.
I leak methane. Yeah. That
Yeah.
happens.
Yeah.
Have I seen this? I don't know. How can I?
I skipped to 456 in the video, and there's the zero fault tolerant. Oh. All right, let's get over there. Let's see. God, dang it! I should have noticed. I should have noticed by now the capsule being there for a freaking hour, just sitting there. That something might be wrong.
That's what I like. That's why I like it, Varix. I like things that go fast. Spacecraft go really fast.
Yep, they do.
I don't know what to do with my hand.
456. Okay. That's Neil Nagata right there. He's a flight controller. And that's Mike Fink. Where am I?
There. Actually, I am going to stand up for a second, guys. See if I can get some energy back into the system. I'll be right back. Just going to go walk around real quick.
Oh, you've got to be kidding me.
I'll be back in a moment.
Crap. I didn't know it was going to happen. Jeez.
Starliner Houston on the big loop. So here's the deal right now. We are 0 fault tolerant to 6th off control, so we cannot technically get into the keep out sphere. However, we would like you to go ahead and fly us in to 200 meters and station keep at 200 meters under manual. And for reference, the attitude that we're targeting is going to be roll pitch yaw 179, 173, and 4.
Okay. No one in chat thought to tell me this? Hold on. No. Somebody must have said something. Hold on. I know you guys better than that.
I'll be coming in 200 meters.
Roger.
There's still some discussions here in mission control with engineers looking at the data from the hot fire test. In the meantime, they're having Butch and Sonny move Starliner to a slightly closer position as they await the results of the analysis from the hot fire test.
They don't have enough thrusters to get into the
The vehicle
keep-out
is still
sphere,
being
guys.
manually
I heard
piloted.
it.
Oh, thank God. Okay. I'm not that stupid. Oh, I kept my headset on. Thank you, past me.
And we heard the call that they do not have the go to enter the keep out sphere due to the current configuration. However, as Jim mentioned, they are flying into near that 200 meter point. The keep out sphere is a 200 meter radius around the International Space Station, sort of an invisible boundary.
I know, he's watching Starbase Live, Baron. See, now I know something's up. See, that
frick you, Stallfire, that's why. The heck is a kilometer anyway? So
I like
they
that
don't
guy.
have they're waiting the results of those thruster firing tests. They don't have enough thrusters.
The keep out sphere and that 200
to enter
meter
the keep-out
radius,
sphere?
again, it's a way to govern the arrival and departure of vehicles. Essentially,
Not yet,
before
at
a
least, Sean.
spacecraft can enter the keep out sphere, it has to be at least 4 orbits safe, meaning if it were to lose control of its thrusters, it would not enter that 200 meter radius within 4 orbits.
Okay, I did catch it, just not very well. Chalk that one up to bad sleep. Something was definitely wrong there. All right, cool. Just wanted to make sure I didn't sit there and go, yeah, it's fine, it's fine, it's fine. It's not fine. It's not fine. It was not fine. Narrator, it was not fine. Still hard to gauge the severity of it. Loss of 6 degrees of freedom of control, Velk, should have tipped me off. I mean, I know something's up now, but like something is wrong. Look, I knew something was wrong there, but I was just too tired to think about what it actually was. I think. I mean, knowing me. No, Elisers, you don't do that. They're waiting for the results from the test. They're not going to go into the keep out sphere unless they're sure of the thruster configuration being good. But it's going to take a second to verify that. What they did tell them is basically to quote unquote line up with the runway. And just stay there. They're getting their approach dialed in, and they'll give them permission to land here, dock with the ISS, pending the results of those thruster tests that they just did. A kilometer is 1,000 meters, or 1 million. Yeah, W. Thank you for letting me know that. Thanks, W. Appreciate you, buddy. I appreciate it. Dude, look at him. I'm pissed. Look at I'm pissed, dude. I'm so mad. look at the anger in those eyes. Yeah, look at what Mike and Neil are doing. Dead giveaway. Something bad is happening here. Oh my goodness. If they can't dock, what happens? Go home. The contingency procedure coder or thruster configuration that they're confident enough to be able to get to the ISS to do. Hey, I got that right. Yes, that is exactly what they're doing right now. All right. Yeah, good job, Path DJ. The final approach with. You can reconfigure Starliner's thrusters. They're individually toggleable. That's how they were able to do those thruster tests in the first place. Yes! Awesome! So I don't think, unless something really goes bad, I don't think they're going to be like, nah, ISS, I'm out. I'll see you later. They were close, though. They were very close. What they'll probably do is tell them to back off and then figure out a way to get there with thruster combination that doesn't utilize thrusters that are potentially leaking. That. Oh, hey, not bad. Not bad, right? Not bad. Tron, 5-month resub. Mini B had a 35-monther before that. Not bad. Not bad. Not bad. Still got it. All right. Yeah, silent. Yeah, 5 hours. No, that's no big deal. That's most likely what's going on, but that contingency takes time. You don't force the issue when you're near your multi-bajillion-dollar space station, right? Hey, am I good or what? I mean, the first part of this I got very wrong. But now, though, hey, all right. Not bad. Especially one with people on board. Why do you place the clip at 20% volume and then scream at us at full volume? Hey, EJ, I'm your mod. Could you make sure that the volume is equalized between the video and you talking? Yeah, weather guy, I'll do that for you. Oh, thanks for letting me know, buddy. I appreciate you. Now, if you could promptly go off and actually be helpful for a change, that would be very useful at this moment in time. No, you just say what you said. That's fine. That gets the point across too. Why is NASA control in Houston? Eutychus, Lyndon Baines Johnson is the short answer to that. Yeah. Kennedy won. Yeah, see, there's the Kennedy spiel. I've given that. I know that speech before. Could they use the arm to grab it? There's no grapple fixture, Halsey. That's a good question. There's no grapple fixture on Dragon, so no. No self-respecting New Yorker would put it in Boston. Well, Rogue Newbie, here's the thing. John F. Kennedy is not from New York. And neither is Lyndon Johnson. So... All right. I've seen enough.
Tranquility Base here. The Eagle has landed.
What's a pirate's actual favorite letter? It's not R, it's the C.
Okay. Anyway. All right, cool. I wanted to make sure that so after they basically said they lost degrees of freedom, I kind of locked in and knew the contingencies, but I didn't get it right to begin with. But then again, it was really hard at the time to figure that out. So I'm I'm pretty happy with the analysis there. That wasn't bad. Certainly things I could do better. Did I miss the update for the Frems thruster check anomaly? We never heard anything about it. Sorry, I'm just scrolling up in chat, see if I missed anything. Curious. Anyway. Okay, so let's so yeah, Starliner is a fuster-click. So Boeing have to figure that out. You gotta make sure the thrusters work, but you also need certification, but you can't get certification unless you're sure the thrusters work. It's a chicken and an egg thing. We'll see what happens, but anyway. Yeah, Cheeseburger. That's the guy's one of my moderators, dude. He's one of the mods in Twitch chat. Don't worry about it, dude. We are good. Hey, Brendan, what's going on? Need to see past EJ recognizing the issue. Nice to see past EJ recognizing the issue is good validation. Yeah. I got some stuff wrong. I could have done better. DOD is back having fun with kinetic energy experiments. I still got some Starship stuff to talk about, but we have to go. Oh, that Starlink moved to 917. Oh yeah, they're dropping it out the back of a plane, Baron. Give me 1 second. Oh yeah, there was also that Rocket Lab news. We got to talk about that. So we'll do the Rocket Lab update. I'm still amazed how close that was to a loss of crew, and NASA Boeing never said anything about how serious it was. It's because they're supposed to keep it cool, dude. Launch a test article just for the thrusters on another rocket first. Andromeda, I think it would be better to use a Starliner for a cargo mission. Test the thrusters. Make sure the thrusters are working. use it for an uncrewed resupply mission, make sure it's working, and then put people on it, certify it, and then fly the remaining 4 missions. All right, so what do we got coming from Rocket Lab here? And I got it good considering the situation. My biggest issue is that you did not clearly remember how severe the situation was, but I can't say I noticed it. I knew it was bad when I heard loss of 6 DOF. That's not good. But, you know. Oh, give me 1 second, guys. Give me 1 moment. Nice. Sorry, guys, I needed to answer this. Cool. Anyway. All right. What do we got with Rocket Lab? So, milestone reach on Neutron's first launch. Stage 2 qualification is now complete, proving out the stage's design operations and readiness for flight. All right. Nice. Neutron's Stage 2 is a novel concept. Unlike most rockets, the 13-meter Stage 2 hangs inside a Neutron's Stage 1 from the top of the tank rather than being supported from the bottom, enabling a very lightweight structure. When Neutron's Stage 1 fairing opens in space, Stage 2 is expelled from within before lighting up its Archimedes engine to deliver the payload to orbit. Nice, dude. That's sweet that Neutron's making moves. Yeah, a lot of people don't know that. Neutron's second stage is hanging. If you take it out of your primary, if you take the stage out of your primary load path, you can make it lighter. Basically, this ring right here is called the load reactor. The load reactor is what's attached to the first stage. This ring with these white dots right there. Did I cover the ISAR launch? Yeah, of course I did, Brandon. Yep, chomper fairing. Okay, cool. Good update from Rocket Lab. It's cool to see that they're making good progress here. Neutron is pretty dang cool. They're testing it down in Virginia, and it's going to launch in Wallops. Doesn't Delta do that? Partially. Delta 4's cryogenic, the DCSS, it doesn't fly anymore except on SLS, but the LOX tank is out of the primary load path. The hydrogen tank is in the primary load path. So it's partially hanging. Yeah, Atlas V does that with the 500 series Atlas. Centaur has what's called a CFLR, a Centaur forward load reactor, to help absorb some of the high liftoff loads, the high thrust loads that are encountered during liftoff on a 500 series Atlas with a lot of SRBs down there, down at the bottom. Do we know what actually expels the Neutron second stage out of the fairing? Jake, if I had to guess, it's probably springs. Springs or a pneumatic push. Could be either one. Anyway, so check this out. This is Niall Ian posting here. 9 hours into the launch of RAM2 from 39A, and they're booking it. Yeah, they're doing tons of work. A lot of work has started on the 39A Starship pad. They resumed a ton of work, which is actually pretty cool. This was news from obviously before From 2. This was the news from yesterday. And then right here, yeah, Niall did the same thing. This is yeah, they've already laid the foundation for the freaking Gigabay. Look at that. Yeah, they did make. Yep. I'm telling you, the 39A pad will get done before the year. The speed they're doing it there is insane. Yeah. Well, they know what to make. That's the important thing to understand, Trey. They know what to make. They've already built one. Well, they're building two. Right? When you know what you need to build, it goes a lot quicker. Which frame is before and which frame is after? That's after. So that's the 20th of March. That's the 27th. They got the pilings done in a week for the Gigabay. Untested, though? Yeah, Silent, you could say that, but Pad B was made based off of what they learned from making Pad A at Boca Chica. Speaking of Pad A, this happened basically right at the beginning of Space News, dudes, but I waited until now to share it. That right there is Booster 14 being lifted onto the pad. Being lifted onto Pad A. Booster 14 flew on Flight 7. That booster has been reused, or is going to be reused, or at least they're going to get a static fire test out of it. That booster has flown. It's been up into space. Now, a lot of people are asking me, like, do I think they'll expend it? I've heard whispers that that's what's going to happen, but I don't think so. I mean, I don't know why you wouldn't catch it again. Targeting a static fire on the 3rd. Cool. Oh, that's cool, Coder. Nice. Dust shield successfully repels lunar regolith on the moon. What mission is that on? NASA's electrodynamic dust shield successfully demonstrated its ability to remove regolith or lunar dust and dirt from its various surfaces on the moon during Firefly's Blue Ghost 1. Oh, that's killer, dude. That was one of the secondary experiments. Yeah. Awesome. Supposedly, they need room for Booster 18, the first V2 booster, so they can launch from Pad B this year. Yeah, that makes sense. Does Starship have a tank D-tank number cap like what SLS has? I don't think so, goalie. These manifolds are mint. What is this? Woof. Look at all those freaking valves, dude. Oh my goodness. Okay. Who took this picture? Oh, Sean Gisler took this for Marcus. Yowza. Wow. Yeah, the fluid management systems, dude. GSE fluid management systems. That's that gets a little complicated. They've added a fair bit of hardware in that gantry structure. Yeah, they definitely have. Here, let me pop over to the live shot here. So that's where we're at. 14 is back on the pad. They're offloading the manifolds from the pad to the surrounding structures. Yeah. Jeez. Mods, can you one time Milgy, please? Thank you. This is what Milgy liked. Oh. Who took this? Oh, who took this picture? Oh, Sean again. Woof. There it goes. So that would have been right there. I wonder if we could see that happening during the day. Oh, Raptor side chat.
European Space 14.
Oh, the high bay. The high bay's still getting wrecked. I'm watching for that crane in the top right frame to move around. This one right here, or that one, it's the same thing. Notice you click over here, it moves. And that definitely has something on it. You see how it's bowed a little bit? It's definitely lifting something. I just want to see when this happened. I think this happened while we were doing space news. Oh, well, he's moving something. Anyway, cool. All right, guys. I was going to end it on the Starship, or the Starlink launch, but that thing got pushed out a little ways. It got pushed out to another hour. When do you think Pad B will get a launch tray? End of the summer is what I guessed. That looks like an empty hook. No 33 static due to confirmation from recent pictures of Starship Gazer due to outers still being warped. It was before the Raptor side. Thanks, Fran. What space engineer showing here? Oh, hypothetical block 3. Yeah, this is Didn't they take one engine off of 14? Yeah. Convergent design, man. It's weird how much this looks like 39A's pad mount. It was just a passing coincidence that it was the same width as the 39A trench. So I was wrong about that too, which really sucks. But all the engines on Booster 14 are flight proven. Yep. All right, dudes. What booster was 314 on? I think that was on flight 8. Yeah, in the Enix, it had the worm on it, which is pretty cool. You still Lincoln Space Engineer, Baron? What's up? Yeah, the new Raptor covers. Yeah, this is a picture from Starship Gazer. Yeah, they have covers for the Raptor nozzles. SpaceX From 2 post at 7:36. Oh. Jeez, man. Let's see what else we got, just in case. During the first day on orbit, the Fremonauts got to work on their research activities, including study on how human cognition adapts to spaceflight environment within the first few hours of reaching space. Amateur ham radio enthusiasts in Berlin and across Europe communicated with yeah, okay. As part of Fram de Ham. Yeah. Crew also completed the first initial Starlink tests on orbit. Dude, ham radio on the back of the dash. Look at that. Oh, that's cool. Oh. Last night during the launch, I saw someone pushing around an engine in the background. Was it a Raptor? I want to know so I can get a better visualization of engine size. It's most likely a Merlin engine, Flykin. The Merlin engines are the engines that they assemble right behind Mission Control. Mission Control is quite actually about 10 feet away from the assembly line for Falcon. It's most likely a Merlin, yeah. How many space junk conversion packs can you fit on a Falcon for 67 million? Depends on... It depends on how your space junk conversion packs. Depends on what's the mass per satellite. The Merlin in the Stargate building was removed today also. Yep. Yep. Okay, dudes. I think I'm going to call it here. There is a Starlink happening in a little bit, but I'm looking through. I don't see much else. Oh, this bombshell. On this bombshell we wrapped today. Okay, what do we got? What is this? Can't play the music. What? Is that? Yeah, that's what I thought that was. Huh. Yeah, see these little guys right here? Yeah. Yeah. It's got some ground effect action going on there. Look at that freaking thing. What's the purpose of this? I'll bet you it's blow stuff up, but whatever. All right, guys. Yeah, it's got some Ecrenoplan stuff going on there. That's actually super cool. I don't know, Tessa, maybe. I'm not sure about that plain weaved carbon. Close enough. Welcome back. Yeah, in-wing motors. You see that? All right. Well, that is going to do it, I think. All right. Yeah, that's going to do it for me, guys. Sorry. If I seem a little bit distracted with the phone and everything, it's that real life stuff that I was talking about. So yeah, this entire stream, forgive me, I didn't want to say nothing till it happened, but my sister just had a kid. So if I've been a little distracted this entire stream, that's the reason why. So, yeah, I'm twice over an uncle now, which is pretty cool. So yeah, I have to, I've been checking my phone, like, and I've been trying to keep it on the down low the entire thing. I didn't want to say nothing until it happened, you know, it's superstitious, you know what I mean? So I got to go give them a call, which is why I figure I'd just tell you now that it's all said and done. I got to go give them a call and Wish them the best. So, yeah. The kid is going to know so much about space one day. Yeah, I hope so. I hope so. Yep. All right. So, I will talk to you guys tomorrow. I would normally stay for Starlink, but I got to go. So, yeah, that happened while we were watching Starliner docking, interestingly enough. Anyway, I'm going to head out. Thank you very much for watching. I'll talk to you guys all tomorrow at noon. I think we'll play Timberborn tomorrow. You guys want to play Timberborn? Play Timberborn tomorrow. All right. I'll talk to you guys all later. Thank you very much for watching. Have a good night.